focused around autoimmunity in COVID-19 since the very start of the pandemic. It has allowed me to be able to take a look at some of the unusual patterns in the pandemic. Hello and good evening, good afternoon, good morning, wherever you are in the world. I'm Dr. Philip McMillan. I'm in the United Kingdom. It has allowed me to be a physician and I've looked at some of the unusual patterns in the pandemic since the very start of the pandemic. It has allowed me to be able to take a look at some of the unusual patterns in the pandemic, and it has also allowed me to meet some incredible speakers from across the world. And today is no different. We have got an incredible lineup of speakers over 2 days. So it's 12 speakers in all, 5 today, 7 tomorrow. In terms of the presentations, it will be my Hello and good evening, good afternoon, good morning, wherever you are in the world. I'm Dr. Philip McMillan. I'm in the United Kingdom. I'm a physician and I've been focused around autoimmunity in COVID-19 since the very start of the pandemic. It has allowed me to be able to take a look at some of the unusual patterns in the pandemic, and it has also allowed me to meet some incredible speakers from across the world. And today is no different. We have got an incredible lineup of speakers over 2 days. So it's 12 speakers in all, 5 today, 7 tomorrow. In terms of the presentations, it will be myself and Joachim Gerlach from Medicinals, who will be doing some of the questions, and we'll be taking questions from the audience as well. And so our focus will be on trying to deal with some of the cutting edge science around what could be happening in COVID-19 in terms of disease presentation, adverse events, and lots of complications that could be on the future. Remember, this is a scientific discussion. And the thing about science is that it asks difficult questions, even when they may not necessarily be convenient. So before we go any further, and we'll let each speaker introduce themselves when they come on, but I'd like you to introduce you to our co-presenter, Joachim Gerlach, and he's going to say a few words and make a short presentation himself just at the start of the conference. So Joachim, how are you? Are you doing okay?
Thank you so much, Philip. Yes, welcome everybody to the 5th Long COVID and Post-Vax conference. And I'm very proud that we have such distinguished and knowledgeable experts today and tomorrow on the panel and on as speakers. So just a short background as to myself. Maybe you want to share the slide, Philip, so I can go through that. We started early in 2020 with our work, collaborating with many of the experts that are presenting today or tomorrow at the conference. And our diverse group has expanded into more than 40 collaborative networks, and with 200 experts working in medical sciences, university levels, integrative medicine, including naturopaths, cardiologists, biologists, pharmacologists, and more from other industry domains. We have, on the next slide, you see we have been working extensively. We did several hundred in silico, in vitro, preclinical and clinical studies on various combinations of molecules and compounds to arrive at the protocols we are currently applying. And a large number of reviewed publications came out of the group of these speakers and our collaborative network. On the next slide, we want to shine a light on, especially in this conference, what are we dealing with? Because many of us, right from the start of the pandemic, were aware of the unnatural origin of SARS-CoV-2. And the data on strange sequences and inserts was very helpful during the development phase of protocols that can mitigate and there's the onslaught to our organisms. The title of today's conference, The Silent Disaster, was chosen because we can observe an unprecedented health crisis manifesting and showing in solid metadata. Here I'm going to give you some overview. On the next slide, you see we have most prevalently the cardiovascular and myocardial disease from thrombosis, microclotting, endotheliitis, myocarditis, fibrosis, heart attacks, strokes, lung embolism, and similar conditions. As an example, here you see one publication showing that leading to myocardial infarction and even death after vaccination. So these kind of cases are showing up everywhere. And if we go to the next slide, the next big field that we want to shine a light on during this conference are neurodegenerative diseases, demyelination disorders, autism, Alzheimer's disease, Parkinson, multiple sclerosis, ALS, and the observed white and gray matter shrinking on MRIs, prion-like diseases. And this can be caused, for one part, by the persistence of spike that has been proven now in many autopsies to be present in the skull and in the meningia of the pathological research. The next slide, that is one of the most worrisome that we are really looking at, is the immunodeficiency. So we can see now widespread opportunistic infections and reactivation of retroviruses, bacterial and fungal infections, and widespread damages to the biome by the SARS-CoV-2 bacteriophage behavior, which Carlo Brogna will shine a light on tomorrow. One example here, for example, is just one of many different opportunistic infections, is this statistic from 2010 to 2022. And you can see that the RSV cases in children are skyrocketing. And we think that is due to the immunodeficiency that has been caused by either infection and or injection. On the next slide, the next topic, one of the big four is of course cancer. And we know and have extensively documented also the problem that is on one hand oncogenic and on the other hand immunosuppressive, which will lead to a strong increase in cancer cases. What you see here is US cancer cases from 2017 to 2021. And until 2019, pre-pandemic levels, we had an average of 1.74 million cancer cases per year. And that is now at a constant 1.9 million newly reported cancer cases every year in the US. So this is a very strong statistic abnormality and cannot be explained otherwise than in post-COVID or post-vax conditions. On the next slide, you see a very rough summary of what else we are seeing is a widespread epigenetic dysregulations, autoimmune disease, metabolic disorders, widespread organ damages, systemic inflammation, systemic amyloidosis, and dysbiosis and intestinal inflammation. So all this together could lead to a higher number of excess deaths, wouldn't it? So on the next level, you see US data compared to pre-pandemic levels. You see that until 2019, there was a yearly death rate of a number of deaths, 2.85 million. And from 2020 on, it is now risen to 3.3 at average. So roughly 500,000 excess deaths per year. Not further defined which cause of death, but a very significant jump from 2019 to where we are now. So the next question is, what can we do? To start with, we must understand the true nature. That's the next slide, Philip, please. The true nature of this incapacitating agent, as Kevin McKern is rightfully putting it. And today, the description that Charles Rixey Kevin McKern, and Christy Grace will show, many experts haven't even taken that into account. So the inserted sequences, the vector technologies, are pretty much at the core of many deep injuries. Also, Dr. Chetty and Dr. Mannen were warning very early in the pandemic about the toxic nature of this virus, and in particular the spike protein. Their contribution to medical sciences and groundbreaking treatments need to be honored. So far, we are on the right track with our approach, and the treatment interventions will be, of course, a topic for tomorrow. So I want to thank all the speakers for being present and being so well prepared and having contributed so much to the field. And I think that we will start now with Christy Grace.
Wonderful. Thank you very, very much, Joachim. And yes, we'll be straight into our discussions with Christy. Thank you, Christy. What we'll ask you to do for us, Christy, is first to do a quick introduction of yourself, say 30 seconds to a minute, and then we'll go straight into your presentation. So you can go ahead anytime you want, Christy.
Thank you, gentlemen. Thanks for having me and everyone that's here today watching. My name is Christy Grace. I'm in the United States. I'm 48. I have 5 majors, actually, including my MSc. And I've been a process and project manager for the largest plasmid company in the world, Aldevron. And then I branched off to do my own consultant work. I've been managing from startups to big pharmaceuticals, recently changed careers, but my specific background is with recombinant proteins, such as spike protein, and then something similar, but LNP and RNA and project development for custom, anything you could think of for biologics. So I'm here to present today on the adverse events and a lot of things that have been overlooked by large media accounts, large accounts on Twitter, and people posting who have been ignoring this data. Thank you so much. I'm going to zip through the slides. I've got over 70 slides. I'm just going to give summaries, and then these are available for download. This is on the lipid nanoparticle concerns, charges, mutations, plasmids, and adverse events. And thanks again, mentioned Kevin McKernan and Philip Buchholz for doing the work that they're doing and working with the plasmids. We're just going to go over briefly what the construction of a lipid nanoparticle looks like with mRNA. You've got the various lipids. There's positively charged lipids. There are PEG, DSPC. We're going to be focusing on the charged particles. The RNA has a negative charge in the center, and that's surrounded by positively charged lipids by electrostatic interactions. And some things have been happening that a lot of people haven't been talking about. There's confirmed studies that the positively charged lipids are causing clots. There's also confirmed studies that if there's an overabundance of these lipids that are positively charged, they'll go right to the lungs and cause adverse events, including clots. So the positively charged lipids, there was a recent study that no one has talked about where they used special analysis and they looked at the lipid nanoparticle with the current injections that are happening across the globe, where the positively charged lipids are mutating the RNA inside that lipid nanoparticle. And this is extraordinarily detrimental. And the one thing that they did not talk about is the exact mechanism and the implications that it would have on the human body, because the mechanism is the same. Human bodies have RNA in it, human bodies have DNA in it. These are called nucleic acids. If the positively charged lipids are mutating the RNA within the lipid nanoparticle, then they absolutely are mutating RNA and DNA within the human body. Then you can ask how that would occur and how it would get into the DNA. We're going to start with the RNA. The RNA mutations are happening because 70% of the RNA that are in the cells of our bodies are outside of the nucleus. So if it's interacting with that, it's going to cause mutations. You're looking at aggregation. There's amyloidosis, all of the things that Joachim Gerlach spoke about earlier. You'd be looking at loss of translation, aggregation, amyloid, misfold, neurodegenerative disease, cancer, you name it, sickle cell disease. The possibilities are endless. Just pull from a big buffet of issues. Then you could ask yourself, why would DNA be mutated? How would they get into the center of the nucleus? The way that they would get into the center of the nucleus is if you had plasmids within the lipid nanoparticle that didn't belong, that are DNA plasmids. The positively charged lipids are connected to those, and they'd hitch a ride into the nucleus and thereby would be mutating the DNA of those cells. So again, this study was proven. They used analysis. It wasn't a hypothesis. With that, you'd be looking at cancer. You'd be looking at dysregulation of more than just P53. A lot of people are talking about P53. There's tons of dead box proteins involved with these kinds of mutations. Recently on Dr. Drew and Dr. Kelly Victory, much love to Dr. Victory. I know she's suffering right now from cancer and our thoughts are with her. Dr. Thorpe and his work with OBGYN. Now he talked about stillbirths, he was talking about the RNA, but the thing is, both the plasmids that are present and the lipid that are positively charged can impact these dead box, what are called dead box proteins. And these would actually be the adverse events that you would see in babies, in children, and it would be involving these dead box proteins that are represented here. And the reason why is if a pregnant mother is injected with a substance, the baby's blood-brain barrier isn't developed yet. It's just coming and going. There's no barrier to stop anything from coming and going. So those positively charged and negatively charged lipids are just flowing in and out of there. And again, there's just so many host of issues that are happening. There's also what's called ion bridging that's involved. I know we went through this really fast. Then there are negative charges within these lipid nanoparticles. And the reason there are negative charges is because the RNA and the plasmids that are contaminating them are highly electronegative. A study that was done in 2019 that was published in the beginning of 2020 looked at the adverse effect of negatively charged lipids on the human body. And what they found are these spindle clots, the same exact spindle clots that embalmers have been reporting on that people have been stating don't exist. It's right in the study, all the references are here. So this would be the cause of these big thick clots that people are finding. And again, that's the negative charge that is impacting the lipid. So again, we're going to talk really quickly about net charge, zeta potential. There's a lipid nanoparticle and how this would change. There's my little drawing of the RNA in the center that's negatively charged, and then you have the positive charges surrounding that. And there have been studies recently done regarding the lipid nanoparticle. In order for the lipid nanoparticle to not have adverse events, it would have to have this neutral charge to it. Some studies were done recently, and there's a webinar on YouTube and a link here where doctors and scientists decided to alter ratios of positive and negative charges within the lipid nanoparticle to see where it goes. This slide is important. This is directly from Pfizer. Pfizer states that their lipid nanoparticle for the current injections is supposed to have a neutral to slightly negative charge. They measured the what's called zeta potential, which is the surface charge of the LNP at -3 millivolts. If it were something different, it could lead to binding events in the blood compartment, aka clots. Now, what would happen if you had a nanoparticle that had a charge on it other than what it was supposed to? These are the original biodistribution data slides that were leaked out of Japan. So again, researchers, they looked at manipulating the charges and they decided, what if we pull out some of the RNA and we had a higher amount of positive charges, if we pulled out the positive charges and we had a higher amount of negatively charged RNA, hence a more positively charged particle, it's going to the lungs. If we have a more negative charged particle, it's going to the spleen, and if it's slightly more negative, then it's leaking right into the vascular, and it doesn't even matter if you inject it into the muscle and if you aspirate. Because of the highly negative charge, it's going to bind to platelets, which are positively charged, and that means clotting. And again, we look back to this Pfizer data, that's an internal document that was released. They admit that if it's not neutral or very slightly negative, you're going to have clots. So the way that things are happening and why adverse events are happening is because one of the issues is the lipid nanoparticles breaking down during the freeze-thaw process. There are more studies, there's 3 or 4 at least that I've included here, where they looked at imaging of the nanoparticle breaking down. So then an RNA might slip out. An RNA is highly electronegative. This means the cell would now be more positively charged. The lipid nanoparticle would be more positively charged. It would go to the lung. It would cause a clot. If the RNA, which is negative, would leak out, again, positive charge. If the positive charge lipids would leak out, then you'd have a negatively charged thing that would go to the vascular, go to the blood vessels, go to the brain, go to the heart. This is a famous study by Dr. Ko that was just done. He is extensive LNP expert out of Korea. So I think he's published about 80 papers. He took a look at the LNPs also breaking down. Also, the lipids are going through aggregation, Oswald effect. A little smaller lipid attaches to a bigger one, it grows. You have by charge, you have what's called flocculation, ion bridging, what we need to talk about as well. But again, these would cause the aneurysms because there's a certain size that biologics can only be. And when the lipids clump together, then you'd have something like this going on. And this would be the thing that's responsible. Another important thing about these contamination is, again, thank you, Kevin McKernan and Philip Holtz for plasmid discovery and the lipid nanoparticle. So when the lipid nanoparticle is formed, you've got lipids involved in RNA. But if these plasmids are in there, the plasmids are getting sucked into the lipid nanoparticle, and then that's going to cause adverse events. So what you have to do is try to calculate what the new zeta potential is going to be in that lipid nanoparticle. So I took all the base pairs of the sequence that Kevin McKernan listed on his Substack. Thank you very much. I took a total of that. So the charge on the one plasmid is now a negative 256. And if we plug that into this equation, which would give you the millivolt of the new lipid nanoparticle, you're looking at the minus 40 range. So you're looking at with just one plasmid would get sucked up into the lipid nanoparticle. You'd have what's called DNA, RNA polylipoplex, and you would have a highly negatively charged particle, which would leak right into the vascular and cause adverse events, misfolding, aggregation. There's so many bad things that are occurring here. Here's what would happen is if a piece of the plasmid was surrounded by positively charged cationic lipids, which is almost positively happening, it would get sucked into the nucleus. And then you would have plasmid hitting the DNA, the SV40 promoter that's on that plasmid, but also you have positively charged cationic lipids entering the nucleus if this is indeed occurring, and then that would mutate DNA and cause catastrophic effects. Also, another thing that's happening, which someone I think is presenting here today, and also Dr. Hazen, is that the destruction of the gut microbiome. There was a study done that is mentioned here that is outside of the current researchers presenting. They took E. coli and they overexpressed protein in E. coli, and the E. coli killed themselves in order to think that they were saving themselves from an evolutionary standpoint. So if plasmids entered the bacteria of the body, and this is very important because bacteria exists in harmony with human cells, at least 1-to-1 ratio. It used to be known 3-to-1 ratio, but 1-to-1 bacterial cells to human cells in the body. It is more important than I think that some people are giving attention to, that the bacteria of our bodies would be altered if those plasmids would hit, and it would be integrated into the bacteria as well. So you have also got via the plasmid, you'd have old viruses. Latent viruses would be reactivating due to interactions with what is called intracondensates within the cells, and these studies have been done. And then in layman's terms, if you had a DNA plasmid entering a cell, it's going to drive cell expression. It's going to make it go incredibly fast or slow it down in ways that you couldn't even think of. Turbo cancer, that's a phrase that's been getting tossed around. You would have, again, dead box proteins would be enhanced, or they'd be misregulated. Different locations in the body, it's just scary and a nightmare of what would happen if those plasmids are in there. Plasmids in the brain, it's known that plasmids in the brain have been studied accidentally would cause microglia scarring. It would cause neurodegenerative disease, ALS, Alzheimer's. Also for human health overall, and the plasmids, there's something called the SV40 promoter, is something that drives gene expression. The proteomics of the liver makes millions of proteins every day. It is responsible for 170 different interactions in the entire human body. So it's not just focalized into the liver. It's responsible, and doctors might be able to chime in after I speak on this or for a Q&A, that the liver is responsible for 170 different processes across the human body. So if you have some plasmids or positively charged lipids that are mutating anything within the liver, you have the potential for impacting the entire human body. Then you've got, so I guess the layman's terms is for the SV40 promoter, there's some laid out here if you'd like to read on that and not get so sciencey for people who don't have degrees. I've laid everything out because I've also been a tutor of science and worked with teenagers for about 30 years and explaining science in a way where people can understand. Like if you had a conductor of an orchestra and someone took the sheet music and altered it in some way, you're going to alter the entire course of what that music is playing, except you just did it to the human body. Or if you changed a stoplight, or you changed a recipe and you were making cookies and you substituted out some of the ingredients and you now made a toxic cookie, and then it would impact things for an incredible amount of time. So I guess for the summary, cationic lipids within the lipid nanoparticle, which are positively charged, are known via multiple studies to cause clots, adverse events, and reactions with the immune system. A recent study was done that the positively charged lipids that surround the RNA that are bound by electrostatic interactions are known and were shown via reverse HPLC with ion analysis to mutate the RNA within the lipid nanoparticle. And again, the one thing that these researchers in the study did not point out, which was very obvious, is if these positively charged lipid nanoparticles are mutating the RNA, causing it to aggregate, causing it to misfold when the spike protein already misfolds within the lipid nanoparticle, and if they came in contact with human RNA or human DNA or even human proteins in any way, whether that be motor proteins, transport proteins, any kind of RNA in the cell that is helicase, doesn't matter. It's going to mutate it and cause a point mutation, cancer, ALS, sickle cell anemia, Johns Hopkins disease, multiple sclerosis, neurodegenerative disease. This is given to a woman who is pregnant and it lands in the womb into that baby, in the fetus. You would see cleft palate, stillbirths, all the things that Dr. Thorpe has been raising the alarm on. It's just a scary nightmare. There's some ancillary things that I've got here. I've got active FOIAs right now because I've worked in the industry for, again, a few years now. And I've very recently this year, changed careers, but I am well aware of some contamination issues that have occurred because I have sources still within the industry. So there, it's diminished. And I've got FOIAs active where the FDA is refusing to respond to me right now. I've been demanding contamination concerns at the sites for Moderna, Catalent, and Pfizer in the United States for 2023, especially the Bloomington, Indiana site, to demand the FDA turn over all contamination records that may have occurred, especially if they had recent steel shavings in June of 2023 and fired their director. I want the FDA to admit that's happening. Again, these slides are there for everybody to view. I just wanted to thank everyone so much. I know I went over things very quickly. Again, here's some slides on the liver proteome and everything that would be happening in the human body. And here is something that is the Moderna patent that isn't really available to the public, that speaks to RNA with LNP expressing over years. I wanted to thank everyone that's going to be in this presentation. I look forward to future Q&A. Thank you so much, Philip and Joachim, everyone that's about to go today. Kevin McKernan, especially for all the work that he's done. Philip Buchholz for currently doing his work. And thank you for the group holding this conference that's been aware of the detrimental effects and everything that they're doing right now to look for promising solutions to everything we're dealing with. Thank you.
Wonderful. Thank you very much, Christy. That is some heavyweight stuff. All right. So why don't we start? Joachim, do you want to start with some of this first? What was your first question?
I have so many, but okay, we don't have so much time right now, so I don't want to hold up the whole conference, but thank you so much, Christy, for coming out and explaining that. What an incredible job you have done there, and great courage to come out in the public with this, because there are now some questions. Okay, the first one would be, have these mutations already been documented by sequencing genome before and after COVID or vaccination? Or should we go about and do that?
Thanks for asking that. Thanks so much again. I know that Philip Buchholz, Dr. Philip Buchholz, who's in either Carolina, North or Southern Carolina, who's a genomics professor, we've been in contact with. I know currently he has requested tissue, exactly what you're asking for, including testing stem cells to see if genomic integration did occur with the plasmids. He's also aware of the risks. With that being said, I'm not suicidal. Philip Buchholz has also messaged me saying he's not suicidal, and that if he ends up harmed anywhere, that was not intentional, and someone nefarious intent probably occurred. So I think that's probably the case with all of us. We're all in the same mental health and happy and good, and we have no intention of harming ourselves or others. But yes, Philip Buchholz is currently testing for plasmid integration, and he's looking at the stem cells especially. But I don't know, and I can't speak to if any has occurred previously or if anyone has that information.
But you're speaking about the permanent DNA integration of sequences of what? Is it because is it then transporting sequences of SARS-CoV-2 or spike into our genome, or other things? What is happening there?
Thanks for asking. The RNA, I like to think of as a blueprint. If you had a 3D printer and you gave it instructions to print whatever you wanted, and in this case, it would be the spike protein, and the RNA would go into that 3D printer and print out the spike protein. And when I talked about mutations of the RNA, that isn't permanent. That's not getting spread across generations, but it can misfold, cause the ALS, the neurodegenerative stuff that we're talking about today, cancers and more, because there are studies that show that non-coding or non-working proteins absolutely are oncogenic far before 2019. There are just years of studies on that. But with the plasmids, those are DNA. So when we speak to science, there's a central dogma of biology that a lot of us refer to as DNA to RNA to a protein. And the plasmids that were used by Pfizer were not entirely reported to the FDA, which Kevin McKernan has also commented on, and others. DNA, if it makes it into the nucleus, that plasmid was the plasmid that made the RNA, and it appears that it wasn't filtered out properly. So it's actual DNA that could possibly either change the way a gene is behaving. So even if it didn't integrate, it could change the way something is behaving. So with regards to all of our cellular processes, all of them, just all of them, it's just a crapshoot where it would land.
Yeah. Let me ask you a question, Christy. So the industry may say, well, in reality, even if this occurs, it could occur only in a small fraction of vaccinations, and it therefore may not necessarily be too relevant clinically. What would you say to that?
Joanna Krieger in Germany in 2021 gave a committee presentation who has far more like molecular in the human level, because I've done the process managing and the design of all this stuff, where I think the medical people are probably, I don't want to like kick the ball down the field, but I can remember her speaking in Germany at a committee for 2021 saying that when we talk about the current adverse events that we're seeing now, she talked to, even if it just landed in a couple of cells and it only changed a couple of cells, if these cells are replicating, like the most cells that replicate, and someone can correct me, are in the gut, in the GI tract compared to the rest of the body. Those would replicate faster if you had a mutation. But in other areas, you might not see this carry over in the daughter cells until 3 to 5 years, possibly longer. So we just don't know. The body might have taken care of it. So I think it's just a combination. I think Kevin McKern's also said, like, where it landed, when it landed, did the body take care of it? Was it with someone who already had a pre-existing mutation? So I have some of the slides like BRCA gene and there's multiple, the CRAS gene. Like if someone already had a mutation present, but they weren't exhibiting symptoms and it wasn't something they would have ever developed, or like if somebody had Hashimoto's or an existing immune system disorder, it could just drive something to be worse. So I think that's a complicated question. And I think alongside others, there's consequences we haven't seen yet.
Wow. Scary
enough. I hope I'm wrong. Please prove people wrong, or please prove someone proves that it's not. Yeah, I'm worried.
I'm just going to take a quick question here, Josh, and before I let you ask your question here, somebody pointed this out, and I think it's worthwhile. What about the adenovirus vaccines? Now, they use a completely different platform.
Yeah. Thanks for asking, Susan. Thank you so much. I used to have a Substack and I deleted and I kind of wrote on that the adenovirus vaccines were experiencing clots because there's a negatively charged backbone, if that makes sense. It has if we think of minus and plus charges being attracted to one another. I know that the study that showed the adverse events from the adenovirus vaccine, because it has a negative charge in the virus, it is attracted to things that have a positive charge. And there are people that have mutations, call it platelet factor 4, so PF4, platelet factor 4. They have mutations in this expression of this. And the people that got the clots had more positively charged things going on in their body with the platelet factor 4. So the negatively charged adenovirus bound to the platelet factor 4 and then caused clots. So that's what was happening with those, but they weren't RNA based. So I don't want to say that they're safer. They have their own host of issues. I would assume they would be less compared to everything we're seeing, especially with now that study that I presented today on the positively charged lipids that can still mutate RNA and DNA and have nothing to do with a plasmid.
Excellent. I'll let Joachim ask the final question and then we'll shift to our next speaker, who is Charles.
Yes, of course, we have I'm always looking at this from the angle of what can be done about to mitigate these processes. So if it really integrates, is it permanent integration into the DNA, then that would be very difficult to treat in any kind of conventional interventions. But to come to the point, the thrombi formation that you were explaining, that is something that is within this group, especially with Dr. Jäger and other practitioners and medics, a big topic. So it would be very good if we could understand better how the thrombi formation is being caused. But these lipid nanoparticles are only there once you have been vaccinated recently. After a while, they will disperse and also kind of dissolve, isn't it?
It would depend. That depends on a lot of things. The LNP, the lipid nanoparticle, vary in size from 50 to 200 is it nanomillimeter. And if they were going to exit through the kidneys, the glomerular pore, again, please someone correct me, is smaller than the smallest size of the lipid nanoparticle. So there's no way they could be expelled via urine, especially if they have aggregated or clumped together, that they wouldn't be exiting that way, and they wouldn't be exiting via pore. They wouldn't, like you would have to, sorry, TMI, like defecate. As far as the charges don't go away. So when we talk about a positively charged or negatively charged thing, those just don't go away. And I know that you and I have spoken before about things just kind of docking in, because they're not just going to be free floating forever. They're just gonna stick somewhere. The body, I think, does have ways to deal with them, but then it's just a toss up, depending on where they landed, how much someone got, if someone got the plasmids or not, how much was injected into them, was what was happening in that vial when that, med tech or whoever nurse injected them. There's so many variables to know, like, and then where it landed, if someone was, had a mutation plate. There's just so much. Yeah, there's just so much. And I know you're doing so much great work with what you're developing and proof of concept and working with, animals and things that we haven't seen expressed in, the other things that are being talked about. So thank you.
Wonderful.
Thanks for everything you've been doing. Thank you.
Thank you very much, Chrissy, and we'll have you at the end when we're having our round table. But we'll straight away be moving into our next speaker, who will be Charles Rixey, and we'll get him to just do a quick introduction of himself right after this flashy bit. Go ahead, Charles, you can start. We're just not hearing you at the moment. Can you say something again? Is your microphone on? Can you hear me? You can hear me, but I'm going to ask you a favor then, Charles. Can we ask you to jump back in? We'll shift quickly to our next speaker in the interim, and then we'll do you afterwards, if that makes any sense. So we'll bring in our next speaker, who is Kevin, who is right here, and we'll just see if we can then see if you jump out and jump back in, and see if the microphone is working at that time. Hi, Kevin, can you hear me and can you speak?
Hi, Philip. Yes, I can hear you. Can you hear me?
Yeah, that's great. That's great. Okay, so we'll get Charles to fix that in the meantime. So Kevin, I'll ask you if you can just go ahead and do a quick introduction of yourself.
Yeah, sure. My name's Dr. Kevin McCann. I'm a systems neuroscientist, and I'm a primate physiologist. I would model neurological diseases, and also back many years ago, as we were trying to understand neuropsychiatric disorders, I was spending a lot of time trying to work out the networks that were responsible for things like OCD, ADHD, that type of thing. So yeah, that's my background. I'm retired now, so I get to speak freely without institutional pressures on me. We just go straight in. I don't know how much the camera is off. Okay, so SARS-CoV-2, we're going to focus specifically on the spike protein. I've given this talk before. This is going to be a very pared down version. And I'm going to state the case that the spike protein, the virus itself, is essentially an engineered prion. I'll explain what prion is in a minute. Incapacitation agent. If you want to get in touch with me, if you have questions, ResearchGate is a good place to follow me. You can DM me from there, and you can see my previous work. It's all publicly available on that site. So I mentioned prions. We need to think a little bit more broad than that with respect to this particular topic, and we need to think about something called amyloids as well. And so this is a very pared down table of what are called amyloidogenic proteins and also the prion proteins. And maybe people essentially, just because of things like mad cow and chronic wasting disease, have maybe heard more about prions. And they were originally discovered in the late 80s, and they were given the designation, the scrapie form, after the disease that occurs in sheep. And what we've come to learn over the decades as studies have gone into prion disorders is that we see similar properties and their involvement in my field, particular neurological disorders. And these are things like Alzheimer's disease, where you would see amyloid beta or tau, and Parkinson's disease, alpha-synuclein. And I've just listed in there serum amyloid A, because you do get systemic versions. But this picture is quite fluid, and we're still very much finding out the precise nature of amyloids and prions. And essentially they can be, you can think of them as interchangeable because of a core property, and that is that they shift, all these peptides shift from having a bunch of what are called alpha helices to developing a hydrophobic beta sheet core. And it's this beta sheet core that essentially becomes kind of sticky. And what they do is that they will stick to other proteins. And initially it was thought that only like would go to like proteins, but as we've come to understand amyloids and amyloidogenic peptides more, we're finding that they can trigger amyloid processes in other peptides as well. And so this makes the landscape of these protein misfolding disorders very, very complex. And so one of the reasons that we've put this meeting together is to, well, I was hoping Charles was going to be speaking before me, and he would be bringing up the rather thorny topic of biowarfare agents. And most people would be familiar with the concept that you would use a bacterium or virus for as a biowarfare agent. But I'm afraid that the bioweaponeers have also thought about using these misfolded proteins as biological weapons as well. They're technically called bioregulators, and the simple fact is that they've shown that you can aerosolize the scrapie prion, and you have an active weapon there. The issue is that they don't disperse very well, and it's difficult to get them to propagate. But the landscape has changed, because what they've come to realize is that these amyloid and amyloidogenic processes can be induced by a whole bunch of peptides, but viral peptides is that's the focus of this talk. And I wanted to just give a quick video of what a prion disorder looks like. This was the first identified transmissible prion disorder. It's called Kuru Kuru. and you're going to see a number of discrete symptom subtypes. And I will describe some of them for you. And immediately what you saw there was what's called choreathetosis. So that's a sort of writhing of the limb. You can see abnormal postural flexing. And I'm not going to play all the videos. I know we're limited with respect to time, but you can see that there are twitches, muscle twitches and tics. And from a neuroscience perspective, these are all, well, for me, very interesting phenomenon, because they track to specific neural networks in the brain and functional areas that I've spent most of my life investigating. So I mentioned we, with respect to these symptom subtypes, we can look to specific areas, brain regions, and maybe from the outward appearance have or generate informed hypotheses as to why you would see these particular manifestations, behavioral manifestations. And on the left-hand side are just some MRI images I grabbed off these from Wikipedia, but these are just MRIs that show that, if I can, maybe I can put a laser, let me do laser pointer. Oh, I think the mouse is better. It's here. There we go, laser pointer. So in this particular instance, A and B, what you can see, these lighter areas around which the mouse is moving, that's the caudate and putamen. These are classically part of the basal ganglia. And C, you can see these bright lit areas. These are regions of inflammation in the cortex. And there's the classic hockey stick sign of CJD, which is again inflammation in thalamic regions. Now, prion disorders, the CJD family of disorders, bovine spongiform encephalopathy, chronic wasting disease, they're primarily categorized by their appearance microscopically of, it's called bovine spongiform, spongy meaning to look like a brain, and you have lots of little holes in the brain as the tissue dies back. Now, I mentioned earlier that with respect to amyloidogenic and prion, I listed a whole bunch of peptides. What we find, and this is from a CJD patient, such as this one from CDC website. You can see here these amoeboid type structures, and this is amyloid. This was one of the, peptides that I listed as what was considered distinct and part of a discrete subset of neurological disorders. And this is what I want to try and sort of hammer home, that again, there's a lot of crossover with these types of disorders we're discovering, particularly at these very sort of fundamental and molecular, physiological and anatomical layers. And so with that in mind, within my own discipline, particularly in the last sort of 5 to 10 years, the concept of prion, the proteinaceous infectious particle, has spread to the description of classical neurodegenerative disorders, in this case, Alzheimer's, Parkinson's, etc. And the key takeaway here is that below bacteria, viruses, we have these proteins, so orders of magnitude smaller than a virus. And it's the protein peptide sequence that itself that becomes infective, and it essentially causes a cascade to a buildup of these infective proteins, and they will propagate and spread as the disease state progresses. And nowadays we think of all these diseases as all these neurological diseases, Creutzfeldt, Alzheimer's, Parkinson's, there are more, as prion-like disorders. And so I need people to sort of think about this when I'm trying to describe the behavioral sequelae or the effects of this, and how that would impact something like the emergence of long COVID, ME, CFS type disorders. So everyone is probably really tired of seeing this picture of SARS-CoV-2, but I just want to use it to help orientate where and what I'm talking about. So I'm going to primarily focus on the spike protein. I'm going to make the contention that that's, for the sake of this talk, that's where we see the most obvious engineering with respect to its provenance, or epitopes that look suspicious. And I would just put forward the premise right now that if SARS-CoV-2 is the product of, and this is, please go and check, look around, do your own research, but biowarfare never stopped, and its research never stopped in the 70s. We have a very active biowarfare medical countermeasures industry that exploded after, excuse the pun, after 9/11. And it's quite likely that SARS-CoV-2 is a consequence of that industry in and of itself, in a best case scenario. I'll leave it to your imagination what the worst would be. And so we're going to focus on the spike protein, and I'm going to point out where the amyloidogenic sequences are and what that would mean with respect to behavioral consequences, short, medium, and long term. So this paper came out recently, just last month. And so people say, well, SARS-CoV-2 is, it's not as serious as the first breakout, and people are not suffering with the extreme symptoms, etc. But the neuroinvasive, or what we could term neurotropic potential, has been identified as being the same. It doesn't matter what the strain is, and it doesn't matter what the initial symptom expression is either. They'll find, of course, this is in laboratory test platforms, that it's capable of passing the blood-brain barrier and lodging itself into the brain parenchyma. So one of the standout studies that really began to crystallize particularly in my mind, that we were dealing with something particularly dangerous with respect to the spike protein, the virus itself, and also the gene transfection technologies which constitute the vaccination programs, was this study from Nystrom and Hammerstrom. And what they showed very eloquently was that the spike protein is studded with multiple amyloidogenic epitopes. And so if you're unfamiliar with these types of studies, molecular studies, again, as I showed you in the earlier, where I showed you alpha helices turning to beta-pleated coils, you can see the same type of diagram, but you're looking at it's a simplified version of the spike protein. And in the bottom row, where you can see these molecular drawings, you can see where, I hope it's clear, that there are different colored segments on the spike protein. And if we look at well, actually, this is all the spike protein, and what we can see is that there are amyloidogenic epitopes, meaning short sequences of amino acids all the way through the spike protein. Now, well, people ask, well, what's the issue with that? It'll get metabolized and the immune system will deal with it. And what they were able to show in this study is that, in fact, the immune system challenging the virus, the spike protein, in this particular instance, a enzyme called neutrophil elastase, causes the spike protein to fragment and break out like a cluster munition and spread these epitopes through the intracellular and extracellular environment. This is particularly concerning because when we look at SARS relative to the other SARS-like virus, meaning MERS and the original SARS, what they've highlighted here in red is that the sequence for neutrophil elastase to bind onto is significantly longer than the previous iterations of SARS and MERS. And again, I would, in light of the existence of the biowarfare medical countermeasures industry, I would encourage you to be very, very circumspect about the provenance and origin of such a significant change with respect to the molecular structure of SARS in this particular instance. Of course, I want to change tack a little bit and talk about more different type of amyloid. And one of the first studies to come out with respect to SARS was from Escherichia Pistorius in South Africa. And what they were able to show is that within the blood circulation, the exposure to spike protein itself causes the emergence of, again, think about Lego bricks stacking together, sticking together and forming oligomers. And what they found was that these amyloidogenic prion-like structures were resistant to the normal enzymatic degradation mechanisms that the blood uses to control for clots. So already we're seeing a number of unusual, not unusual per se, but a stacking of properties that look, only 5 minutes remaining. I need to run very, very quickly. I've taken too long. But again, we see multiple levels of the emergence of amyloidogenic proteins. And to complicate the issue further, when SARS first emerged, there was a big brouhaha about the inclusion of HIV-like epitopes, and this got jumped on very, very quickly from up on high. They tried to squelch this. This is just a 3D representation of that spike protein. The yellow dots at the top are these HIV-like sequences, and also they're present in something called the furin cleavage site. And what I again want to do, I'll skip that slide, is point out that these peptides, the HIV GP120, is identified as being amyloidogenic as well. Now, concerningly, what we've seen, and just by chance we have this study, was that someone who was due a PET scan for Alzheimer's had received a vaccination the day prior to going into the scanner. And we see the binding of the radio-labeled ligand to amyloid beta in this individual. And we can see it at the injection site and in the lymph node. And again, think about these amyloidogenic peptides sort of building out like a, I don't know, trying to think of an appropriate analogy beyond Lego, but just think of them sticking together and forming these very unwieldy protein structures. If we look at the open source sequences of where the amyloidogenic sequences are with respect to the wild type sequence, both the Moderna and Pfizer vaccine have the same distribution, and the in fact, codon optimized in this particular case, of these amyloidogenic sequences. And like I said, this is very, very concerning, coupled with the observations of Jean-Claude Perez, Claire Marais-Charmin, and Luc Montagnier, who they found a 260% increase in Creutzfeldt-Jakob and on average, 11-day emergence of what they are calling a new variant Creutzfeldt-Jakob. Now, I want to talk a little bit about excess deaths. Now, the pandemic has been marked by a wave of all-cause mortality, and people would generally think, well, that would be COVID, right? Well, that's not the case. If we look, so this is data from a year ago, and I updated it today. And where do we see the majority of deaths? Well, primarily within the cardiovascular, hypertensive diseases, so think of the microclotting, but also Alzheimer type diseases and dementia type disorders. Now, maybe the all-cause mortality is dropping down, but this is data from the ONS in the UK, and the left-hand side would be the younger generations, and we see particularly this year and last year, a very, very large increase in all-cause mortality in that particular bracket when we shouldn't expect it, and a natural pandemic should have long passed us by. So, of course, there are hypotheses now about potential prion involvement in long COVID, the number of papers there. Of course, Stephanie Seneff will be presenting today. I want to point to this. Well, you can say that's just hypothesis, but I want to read out this paper, which was published in 2021. And well, I'm not going to read it because I'm short of time, but basically they show that the spike protein from SARS-CoV-2 can cause prion-like propagation in this disease model. So yeah, I'm out of time, and I probably got about a third of the way through of what I wanted to present. So, but actually, it's a good place to stop. It's a good place to stop.
Yeah, I realize. So not to worry, we'll have a little bit of discussion, and some of these points we can bring up when we come to our round table, if you wanted to highlight any specific issues. But I'll let Joachim start with regards to the first question, so to speak. Joachim, any questions? This is again another huge, significant scientific kind of look at what we're facing. Any first thoughts, Joachim?
Yes, I mean, thank you so much, Kevin. And I've been listening to you and looking at your work since quite a long time, and I don't know how many hundreds of hours I spent listening to your life explanations on what's going on.
I apologize for the lost IQ points.
No, it's not fine. And so, yeah, maybe it needs to be understood. And the question is, how bad will it be? Because as you, and also when I met Nystrom and Hammerstrom, they both also agreed upon that there is no safe dosage on prions, as they proposed.
That's a sort of axiom within neuroscience, that there is no safe dose, and it comes down to the body's ability to be able to clear them. And some tissues and organs are going to be better than others, and when you're dealing with something as sensitive and complex as the brain, we're essentially still feeling our way in the dark somewhat. I mean, the second half of my presentation, I was hoping to show some of the primate work and what happens with respect to the brain in not SARS, but where the body isn't reacted or is going through a disease state, and we see these neurodegenerative states emerging. And in that particular instance, we're so at the base of the mountain with trying to get a understanding here with what's going on, how the body deals with it. And all I could say is that there's going to be a spectrum of responses. Some people will be acutely sensitive to it, and some people are just not going to have any issue at all. And the example I give is allergies. So some people just have to get a tiny bit of pollen, or in my case today, cat hair fur, and you have an allergic reaction. My wife and kids, they can handle and throw those cats around no problem, and I don't. It's just different strokes for different folks. So
I'll tell you what I was interested in, Kevin. The image that you had with regards to the amyloid change after vaccination stood out to me from a clinical point of view as very, very important, because as you pointed out, everybody's on a different spectrum of where they are. And so you may find that people who had mild cognitive impairment with regards to the increase in amyloid could have a progression where their little forgetfulness suddenly becomes mild dementia or moderate dementia. And you see this very stepwise change in symptoms, but it's very subtle and very difficult to be correlated. Is there any way that we would be able to try and identify these patterns?
It's a good question. But if I was designing an experiment for my monkeys, the way to be doing that would be, well, there'd be quite invasive methods, so that's not possible. But with today's modern MRI scanners, the higher Tesla scanners, I would perhaps recommend T2 FLAIR imaging and try to look for iron aggregation in the brain. I didn't get to it in this talk, but that's the one thing that really stands out to me in the spontaneous neurodegenerative disorder that we've managed to capture in monkeys. And this, I was hoping to sort of emphasize to people that in terms of neurodegenerative disorders and things and complex disorders like long COVID, ME, CFS, we have very, very little idea. And I'm the only person to have found in all the decades that we've been researching these Parkinson's, Alzheimer's type conditions, where we have very specific models, a early onset version of it. And the one thing that leapt out at me beyond all the other the theories around protein misfolding, etc., was the rapid and heavy accumulation of iron in both basal ganglia and cerebellar deep nuclei. And that would be my suggestion right now. Track that.
Yeah, any final question? That we'll have to probably move on to Charles if his speaker is working in a bit. But yes, this is some heavyweight stuff, very concerning stuff as well, and it probably fits clinically with what may be happening. But Joseph, go ahead.
Yeah, very quickly, I still owe you the iron aggregation ferroptosis kind of research I have accumulated, so I'll send that over fast. But the other one is also and we hear that later from Dr. Manan, is the idea of looking at tackling these problems in a broader way. And we will go, we prepared a presentation that Manan will show later on how to recalibrate the whole lymphatic system, because that's all disturbed. So let's say the cleansing of the brain and the CSF is completely blocked, and so the accumulation of that will be accelerated again. Like in this disease, you can see always 2, 3, 4, 5 factors coming together and creating something like a turbo progression in whichever disease angle you want to look at. Yeah, but then I won't ask many more questions. We do that later at the round table, maybe after we also have listened to Manan, and let's move on to the next speaker.
Sure. Wonderful, wonderful. Thank you very much again, Kevin, and we look forward to having you at the next phase of the discussion. So we've got as well with us Charles. Charles, can you say something? Hello?
Yeah.
Whoops. Yeah, go ahead, say something again.
Can you hear me better now?
Yeah, okay, wonderful. We're hearing you now at the moment, Charles. So Charles, I'll ask you if you could quickly introduce yourself so that we can get a better idea as to who you are and what you'll be presenting about, and then I'll share your slides for you.
Well, I can present them if you need. I can.
It's just that I haven't uploaded them, so it's probably easier for me to do it for you at the moment.
Okay. Well, my name is Charles Rixey, and I spent my career in the military in the United States Marine Corps as a chemical, biological, radiological, nuclear defense specialist. And I also worked 8 years with part of that with the Department of State. And so I'm very familiar with weapons of mass destruction, biological weapons in particular. I used to teach this both for the Department of State and at the Marine Corps Seaburn School. And so really, since the pandemic, I've been working with Drastic, with scientists who were really working like with Kevin and a lot of work in this area. And specifically today, what I'm going to be speaking about is basically SARS-CoV-2 through the prism of gain-of-function research and how what the implications are for past and long COVID. So, I don't know if you can zoom in or.
Yeah, we're hearing you still, Charles. Go ahead.
Okay. So let me go ahead and open this up. You can go ahead and go to the next slide. So basically what we're going to talk about today, and forgive me for my humor, but I'll kind of go through what I saw with scientific censorship, because that was the first thing that I was researching during the course of the pandemic. And then we're going to talk about what is censored and why. And specifically because that has direct implications to everything that we're talking about in this conference. Next slide. So basically, as Kevin alluded to, very early on in the pandemic, an awareness that there was a pure and cleavage site in this virus, and of other certain epitopes. Scientists around the world, they understood these epitopes to be bad, and they made decisions not just to hide the fact of their existence. They then kept those epitopes in RNA jabs. And so, next slide. This is just kind of showing the connections between, there's very famous meetings that took place, one on telecom 2020. And during that meeting, Dr. Fauci, Jeremy Farrar, and a bunch of others got together. And outcome of that meeting was basically a decision to hide the pure and cleavage site, hide these HIV-like epitopes. Next slide. So on the previous slide, it was basically a list of papers that were born, that came from the first meeting. This slide is just showing the funding of, well, it shows why this matters. Because Dr. Fauci and the NIH by themselves control almost 60% of all biotech medical public funding on the planet, just by themselves. And then the European Union has another 8%. So they control what gets into, this trickles down into what happens with the literature. Next slide. The scientific consensus around a natural origin is actually a 13% consensus. I went through, in this case, when it's 2,500 articles and news articles, etc. And scientific literature, even within the scientific literature, there's almost always a 2-to-1 ratio in terms of most people believing that this was
You seem to be cutting out temporarily. Can you just speak a little louder? But just did you want me to move to the next slide?
I'll speak louder. All right, so you won't be able to see this very clearly, but what this is showing is that in the top 6 journals in the world, let's see, well, I can't even see it now. But there were, if I remember correctly, 193, I'm sorry. Okay. Well, basically 97% of articles in the top 6 journals in the world, Nature, Science, Cell, The Lancet, PNAS, out of, I think it was about 258, there were only 7 articles that were even open to the possibility of a lab origin virus. So that's all this is showing. Next slide. All right. This is where I took all the articles that came out, and basically what I showed is that the narratives that they had in the scientific literature, they came in a series of waves. There's a big push at the beginning, but then it was only after March of 2021 when they realized that the lab origin narrative wasn't going to go away, and so you kept seeing these efforts. And every time that bad news came out against the natural origin, they would come out with a flood of papers to go against it. Next slide. I'm not going to have time to really go through this, but this is just showing the intensity of the bias for various publications. And you can see the 6 major article or journals highlighted in red. You see Nature at the top, Science. And so the number, as you go up along the x-axis, that's the number of articles on that or in that journal or publication. And y-axis shows the intensity of the bias. I'm sorry, the x-axis. I think I said that backwards, but the intensity of the bias is along the bottom. And then what we see is basically that newspapers and TV and independent journalism, for the most part, by a 2-to-1 ratio, leaned in the lab origin, and almost entirely in the scientific literature and in the top scientific literature that we saw this massive suppression of anything else. Next slide. This is just an example. I went and I took, basically I showed that there was artificial exponential increases in followership amongst various scientists on Twitter, as well as suppression at the same time of other scientists. And so this is just an example of that. Next slide. All right, and so now we're going to move into what they were wanting to censor. Next slide. So as Kevin alluded to, there are 2 specific pieces that we, not just 2, but these, the furin cleavage site, and then what are called like the HIV inserts, that were the first discovered on January 31st. Further research later on showed just these inserts. Luc Montagnier and Jean-Claude Perez showed that there's actually entire much longer sequences that were homologous with various HIV sequences. Ones that we're going to focus on. Now, first, we're going to talk about furin and shows why furin is important. In the original SARS virus that emerged in November of 2002, receptors that it targeted were ACE2 and TMPRSS2. And you can tell that what parts of the body that the cell tropism the virus has. And then for SARS-CoV-2, you can see that a massive difference with what furin is capable of, the tissues that furin is capable of entering. In fact, I believe it was Stephanie Seneff in a video. SARS-CoV-2 uniquely can enter into 28 out of 55 human cell tissue, and that is unprecedented in human history. Next slide. This is just showing that for 6 weeks after this teleconference, they continued to hide the evidence of the furin-cleaved site and of these HIV inserts. I went through and I made a list of every article that was written by the attendees of these teleconferences, and out of 33 articles in those 6 weeks, none of them mentioned the furin-cleaved site. They waited until what was an article called "The Proximal Origin of SARS-CoV-2" came out to have that set the narrative. That made a very big negative difference. Next slide. And so why does this matter? Well, the furin-cleaved site has always been removed from vaccines. This is an excerpt from a book where they were talking about the development of vaccines. And in here, what they say is that Barney Graham, the person who made the decision to retain the furin-cleaved site in the Moderna vaccine, as partnering with the NIH, he said that it was counterintuitive that they would do this. And we're going to show you why. Next slide. This was Philip Dormitzer back in 2014, sitting next to Ralph Barrett at a conference right when the gain of function ban began. And during that conference, and by the way, during that conference, what he said is that if one is making viruses and intentionally for use in manufacturing a vaccine, and if I knew that there was a certain genetic motif that correlated with high transmissibility, I would make sure I did not include that motif in that virus. Just as today, if there's a virus that has a polybasic cleavage site, an HA, which is associated with virulence, sure. In fact, we have a rule in our lab. We do not make flu viruses with that motif there. So there's utility in knowing what the bad actors genetically that you really don't want in your virus. And that was Philip Dormitzer in 2014. And in 2020, or actually in 2015, he moved to Pfizer. And so he was in charge of vaccine development for Pfizer when they made the opposite decision. So we have the manufacturer of Moderna and the head of the Pfizer vaccine both saying in the last decade that we would never retain furin-cleaved sites in viruses. Next slide. And this slide simply shows, I went through, I've actually updated this since then. This is 26 studies. I've now done 49 studies where I've shown that over the last 3 decades, whether it was RSV, HIV, flu, MERS, or SARS vaccine candidates, they always mutated or removed the furin-cleaved site until Pfizer and Moderna in 2020. Next slide. I put this as collateral damage. Why does this matter? Because just Moderna and Pfizer produced almost 9 billion doses. I don't remember exactly how many were administered, but we're talking in the billions of people. And so what the rest of my brief conversation, we're going to show, well, next slide. All right. So one of the other things that they hid, one of the many types of drugs that they hid was what's called peptide fusion inhibitors. And the reason that they hid this is because the SARS-CoV-2 is what's called a class 1 fusion protein in terms of the fusion protein virus. One of the homologous regions that it shares with HIV, China and other countries have shown in vivo and in vitro that peptide fusion inhibitors stop SARS-CoV-2, and they found that it also works against HIV, HIV-2, SIV, and all of the Omicron variants so far. Next slide. This is just another list of studies showing the Chinese research going back through, well, for decades, showing their fusion peptide inhibitor research. And once again, this is just one of the classes of drugs that we're talking about. Next slide. Still no plan to research fusion inhibitors. This is BARDA's strategic plan through 2026. Next slide. Why does this matter? Because Dr. Fauci just dispensed $577 million to 9 centers to study different antiviral drugs, and $0 of that is going to go towards fusion peptide inhibitors. Next slide. All right, so last is implications. Next slide. So all this is simply a timeline showing various studies along the path that could have produced all the science necessary to produce a virus exactly like SARS-CoV-2. And I've included who did it, the collaborations between all the scientists, etc. Next slide. Why is this important? Because the HIV inserts that were discovered by Pradhan et al. On January 31st of 2020 also happened to be, not by accident, 4 of the most important antigenic epitopes within the virus. Next slide. Slide. I don't have time to go through all this. All right. Next slide, actually. I'll explain. So, since I don't have much time left, what I really wanted to focus on is that they understood these epitopes. And we know this because in addition to the furin cleavage site, they also, in looking at all of these things, they knew about these HIV inserts. They said that possible that these epitopes could be of value, but here, in looking at their own studies, it shows that they would always remove these bits from slide. This is just another study, once again showing where they would be removing epitopes. So when they make back out bits and pieces that were nasty that they didn't want to keep. And once again, the opposite occurred with the SARS-CoV-2 virus and in the vaccine. Next slide. This is just another of the same type of study. Next slide. Another one. Next slide. Like I said, I just want to show you that the evidence does exist out there. In this case, they were looking at scorpion toxin mimic of CD4 in complex with human HIV virus GP120. And whenever they were making these different things, these different compounds, they would always remove these specific nasty pieces, the same pieces that were then retained in SARS-CoV-2. Next slide. Other example, we don't have time to go through it, but this is showing you exactly what I've said. And this is an HIV in viral vaccine candidate itself. Next slide. Yet another one. Next slide. This is showing, these are HIV target antibodies. And what they don't tell you is that many of these same antibodies are generated by people during SARS-CoV-2 infection, specifically the 2G12. Next slide. Here, I've listed a whole bunch of different epitopes. Once again, we don't have time to go through them, but this isn't all of them. But this is just the majority of dangerous epitopes that are inside the spike protein that were retained with codon optimization inside the vaccine. And what I also show here is that on the right-hand side is that the majority of mutations in the viral genome or in the spike protein, as it mutates over time, are taking place directly in the vicinity of these suspicious inserts, which is basically saying that this is the virus trying to shed this unnatural these unnatural bits. Next slide. All right. So just real quickly, just in 29 amino acid sequence, I think 29, my math might be wrong. Yeah, it is wrong. But in this short sequence, it's consecutive and there's 4 bad bits. The first is a super antigen, which used to be stockpiled as a bioweapon during Cold War. Also the furin cleavage site, ENAC, and then pion-like domain. Next slide. And I'm running out of time here, but the bottom line is that they understood that these epitopes were bad. That's really the point that I wanted to get across in my presentation. And anybody that wants to go, I have links that I can provide that have links to all. I have an Excel spreadsheet that has all of those links that you saw there that you can go and click and read the study yourself.
Excellent, Charles. I'm sorry we had to stop you there. This is some heavyweight stuff again. I can say that the speakers have brought some really cutting edge information here in front of us. And I guess my question to you from the point of view of your research is, well, what is your conclusion based on that? Do you think, what are the chances natural versus lab origin based on your research?
So it's it's basically mathematically impossible that this is a natural virus. There's what Stephanie Snapp pointed out. The tropism is inhuman. We've never seen anything like it. Wouldn't see evolutionarily. A virus would never need that many different tricks to be able to infect a person. So everything that we see leads us furin cleavage site, and these inserts are driving, at least in terms of the spike protein, are driving a lot of the long COVID type stuff that we're seeing. And I shouldn't say it, not a lot. In addition to what Christy Grace was talking about, but spike itself within the infection, you're seeing immune suppression, and that is really what we have to stop, because that's the target of this virus. And so one of the reasons I love what you guys are doing is that you're looking holistically at this problem. I think that's absolutely the best way to go about it.
Joachim, any question? You're muted at the moment, Joachim.
Very sorry, I didn't want to disturb you. Thank you so much, Charles. First of all, I know that you have been sacrificing practically your life to bring this together. And in the group drastic, and what you have done is of very, very incredible value to all of us. And I think I would have a very quick question. One is, which I didn't understand, the furin cleavage site, is it still fully functional in the version of the vaccine?
From what I've understood from the research that Dr. Richard Fleming did with Luc Montagnier and others, there's so many different aspects to this, because it can be functional, but what we're seeing indicates that it is, or at the very least that the epitopes are still able to cause damage, because we've seen, and we were seeing this prior to vaccination. And I think that one of the biggest problems, obviously, is that when you get infected with the virus, you get 50 times less virus than you receive, for instance, in the Moderna vaccine in a single dose. And so a natural infection, you're able to overcome these things. So issues with the spike, say if the 2-proline substitution is causing improper cleavage, etc., it's still a massive batch of bad, like the statistical probability of something bad happening is bad, and that's before you include anything with the lipid nanoparticles and the plasmid, which I think in the long run is driving much of the problem.
I just wanted to jump in there on that point that you mentioned. So just to make it clear for people is that I think the mRNA platform did try to adjust the furin cleavage site, and they put in 2 proline substitutions, I guess, to try and neutralize it, similar to the receptor binding domain. Do you think that that helped, hindered, made any difference?
Well, like I said, in all previous studies that I saw for over a decade, that either mutated or removed the furin cleavage site. So they believed that it was incredibly important to do so, and they said it themselves. So I'm not a chemist, I'm not a scientist, so I can't speak to. But what I can say is that the 2-proline substitution is the real problem was just retaining the furin cleavage site, retaining these other epitopes. Proline substitution is just an excuse to have it stay in its pre-conformation or pre-fusion conformation. I don't think it was a plus, because they shouldn't even have just used the spike protein if they were going to vaccinate. So in any situation, it's bad, but it's the retention of the furin cleavage site and these other epitopes that really makes the spike as bad as it is.
Wow. A final question to you, Georgia.
Yes, I have one really important question. I've been looking at the list of these dangerous epitopes since early in the pandemic, and you have added an enormous amount of additional, let's say, questionable inserts. And so are you aware of anybody in the industry from the pharmacological side that is looking at these epitopes and all these GP120 like inserts and whatever, just name it, in order to try to develop compounds or interventions that can help mitigate the problems caused by this funny protein?
The short answer is no. In fact, what I've been hearing is the exact opposite. Fauci went out of his way, and Francis Collins, to avoid funding long COVID studies. And I spoke with people from different labs across the world, but especially in the United States, who were saying they were trying to do studies on long COVID and PAS and look into these epitopes and stuff. And just like with the fusion peptide inhibitors, what we saw was that they were, instead of funding these things, they're pushing attention and funding away from all of these problems, just like they're doing with the lipid nanoparticle and the plasmid. So
shouldn't we take this as an occasion to call anybody that is listening and capable and has deeper understanding of sequencing and of molecular biology to give us a hand in understanding, modeling, and finding out what exactly the epitopes are doing and how they might be mitigated by certain compounds or interventions?
Absolutely. I think, like as I said, what I like what you guys are doing is you're looking at this holistically. You've been doing it since the beginning. And I think that's absolutely the best approach to it.
Excellent, excellent. Thank you very much, Charles. And as we step along, and we'll be able to ask more questions towards the end, but we'll move straight into our next speaker, who I'll ask to unmute, which is Dr. Shankara Shetty. And Shankara, I'll again ask you to do a quick introduction of yourself, and then we'd love to hear your view, as we have heard many times before, on what's been happening.
Thanks, Philip. I'm Dr. Shankara Shetty. I'm a general practitioner and natural science biologist, and I've been observing clinically the presentation of COVID long COVID, and some of the vaccine injuries, and trying to bring understanding to it, to understand the pathophysiology and figure out some treatment interventions. It's been a long journey, and yeah, I hope I impact on the general practitioner's ability to treat a lot of the side effects or effects that we see.
All right, go ahead, Shankara. You can go ahead. Are you going to be sharing something, Shankara?
Yes, I want to share my screen, Philip. And
okay. What we'll do, can you, it may take a few minutes to upload. Did you by any chance send me an email with it?
Yes, there's PDFs on an email, Philip.
You sent me an email?
Yes.
Okay, I will get it up. Yes, I will get it up for you. Is it the hypersensitivity? So I will bring it up. It's probably easier for me to share it.
There's many PDFs there.
Oh, right. Which one do you want me to share?
I'll start with one, and each one's a PDF.
Okay, I will get them. I'll get them in place for you. And so you can just keep generally talking while I get this ready for you.
Okay, let me just get back to you. There. Okay, Philip, the understanding of hypersensitivity, just a journey through what I've done with COVID itself. In early 2020, I started examining patients, and like every general practitioner, any doctor does, when a patient presents with an illness, we examine the patient, and from the clinical presentation of the illness itself, we try and figure out what the underlying pathophysiology is, and of course, institute treatment appropriately. So every patient is basically a clinical trial. So we suspect the disease that the patient has from the clinical symptoms, and then we do a clinical trial. And if we have good speed to recovery, then we tend to think that the hypothesis was correct. And this was the methodology I wanted to use when it came to understanding COVID illness and understanding the way it presented with symptoms and the way to negate that. With an understanding of hypersensitivity, just a broad understanding, hypersensitivity is triggered by allergens or antigens and can be toxins or proteins that are from bacteria or viruses. They can trigger an immune response from the, there we go, understanding hypersensitivity. They are mediated by immunoglobulin E. And this requires a previous exposure. Type 1 reactions, they're very rapid in onset, like a bee sting that you're allergic to, and very aggressive with mast cell degranulation, and they lead to a chemokine storm that increases vascular permeability, causes edema, and we all know about the swelling of the base and the throat and things like that. We, as GPs, know how to treat that. It requires specific interventions to mop up those cytokines and to turn off that immunologic tap. Type 2 reactions are rapid in onset, but not as aggressive, and involve chemical mediators like platelet activating factor, and so cause microclotting, and of course chemotactic factors that result in inflammation and coagulation. Both these reactions, if left untreated, spiral into complications as they attract more and more cell mediators and cells to the site of the problem. And bringing those cell mediators to that site results in injury that results in a longer term of recovery, and requires a lot more in the ambit of treating that patient. So when it comes to these kind of reactions, quick intervention is absolutely important. Now, I separated my presentation out into the first and second wave. The first and second wave, clinically, the presentation was very unusual. Clearly, it was a biphasic illness that seemed to change on the 8th day, and that's where my initial publication came from. The clinical presentation in the early viral phase was just a sore throat in both very simple localized symptoms. The first wave presented in the viral phase with a sore throat, loss of smell and taste, simple upper respiratory viral symptoms. And in the second wave, it presented with more gastrointestinal symptoms. And in both these waves, that initial presentation completely resolved within that first week. So I had patients who thought they were over the illness completely. Clinically, well, exercising, back in sport, back to normal life. In both these waves, on the 8th day, there was a reemergence of different symptoms. And that reemergence was very sudden and very aggressive. Patients in the first wave would come in on the 8th day, feeling tired, became breathless, and immediately oxygen dependent, whereas on the 7th day, they were perfectly fine. And I found that the severity of the initial viral illness didn't have a bearing on the severity of the second phase of the illness. And its onset and aggression in the second phase drew my attention to a very specific set of pathologies that could cause this. There are only two things that could trigger this kind of sudden aggressive decompensation, and that is usually an allergen or a toxin. So my understanding was that we're dealing with some kind of allergenic process in the second phase that was triggering a sudden release of chemical mediators that were causing the problem, very similar to an anaphylactic or anaphylactoid kind of reaction. This reaction seemed to be occurring in the lung. Now, remember, in the first wave, the viral phase never influenced the lung. Patients recovered. And this second phase suddenly influenced their ability to breathe. Clinically observing these patients, they had no fluid in their lungs. They could inhale easily. They had no obstruction to airflow, but there was the limitation to the elasticity of the lung. And so they couldn't, they had no way to take a deep breath, basically. So let me just, they had no way to take a deep breath. So it required from me to consider how to treat this if it was an allergic reaction. And my theory underlying this presentation was, I'm likely to be dealing with the type 1 hypersensitivity kind of reaction. And understanding a type 1 hypersensitivity reaction, the treatment intervention usually involves steroids, antihistamines, dependent on the target tissue. We have different antihistamines that affect, or histamines that affect different tissues, and different antihistamines that need to be used depending on the target tissue. Leukotriene inhibitors, because leukotrienes are released in this type of type 1 reaction. Mast cell stabilizers, platelet activating factor, though platelet activating factor is not a very common secreted in any quantity. And then optional interventions included things like adrenal and nebulization for those that had already decompensated and started to get crepitations because they had presented late. And of course, bronchodilators for those that had any bronchospasm or prone to atopy. Understanding the intervention, the one thing we do as doctors to understand that we're on the right track is to understand the speed to recovery. And the speed to recovery tells you that what you're doing is correct. And of course, with withdrawal of treatment, is there any rebound? Now, in the first and second wave, I found that when patients decompensated on the 8th day, if you were quick and aggressive in your treatment, the clinical recovery was almost immediate. Patients, no matter how sick they were on the 8th day presenting, showed dramatic improvement the next day back to almost normal. So this shows that there isn't very much cellular involvement in the inflammatory process, like in a type 1 hypersensitivity reaction. However, if you leave a type 1 reaction with this chemical storm unchecked, like in late presenters who didn't get to me on the 8th day, you find that it spirals and it causes a chemotactic release of mediators and, of course, inflammatory cell involvement. And that requires a longer course of treatment, and there'll be some sort of injury persistent from that storm. Then we went on to the deadly Delta wave. Now, in the Delta wave, there was a change in presentation of the second phase. The second phase of illness, patients presented with fatigue. It was quick in onset on the 8th day, but it wasn't as rapidly progressive as in the first and second wave, where patients deteriorated within a day. However, I noticed in this wave that we needed a far higher dose of steroids. So the antigen that triggered this reaction seemed to be far more toxic. The speed to recovery was relatively slow. And so when I looked at that, I considered we might have shifted to a type 3 type of hypersensitivity reaction, where we're dealing with an antigen antibody type of complement that type 3 type reactions tend to address. And with these kind of reactions, there is a production of platelet activating factor in abundance. This leads to coagulation, microemboli in the vessels, and anticoagulation became critical. At this point, because of the slow recovery of patients, we couldn't use clinical improvement to assess the treatment intervention success. So we had to use biomarkers to gauge the severity of the illness and to adjust aggression of treatment in different directions. Interleukin-6 values were initially raised, followed by CRPs, and then we saw D-dimers go up once the microthrombi started to happen. This required us to add strong anticoagulants to our treatment, the likes of Xarelto, clopidogrel or clopidogrel, and they showed great benefit. But unfortunately, with this wave, if patients did not present early, the coagulation cascade moved on, and the oral anticoagulants didn't work, and they required to have heparin. But of course, with heparin, by the time you got to that point, patients were sitting with thrombocytopenia, and because of the low platelet count, we saw with heparin that we had a lot of bleeds with patients trying to be treated. The change in the pathogenesis was based on the observations, and I thought that we're dealing with more an immune complex kind of illness that was in the Delta wave. In the first 2 waves, type 1 hypersensitivity, the reason I looked at that was speed and aggression. And of course, you could clear the disease away within a day. Like a bee sting, you can have a patient well within the day. And of course, I postulated in the first wave that there was some kind of sensitization that occurs to produce IgE in these type of reactions. And we saw in the first wave that people over 55 were more prone to getting the severe part of COVID. And of course, I thought that 55 years and longer ago, these people were exposed to something that sensitized them, and people born in the last 55 years were not. And of course, looking back to try and figure out what that might be, the only thing that I could place my hand on was the wide use of DDT, which stopped about 50 years ago. And that might have been the sensitizing agent. The people below 55 in the first wave would have had relatively asymptomatic infections, but that would have sensitized the susceptible population in this age group up to 55 in the first wave. And so I expected that in the second wave, we'll see younger people die. And that's what occurred around the globe, irrespective of the variant affecting people. That cemented my view that it's type 1. When we got to the Delta wave, things changed. And I realized that we're dealing with a different kind of a hypersensitivity reaction. After the Delta wave, we went on to the Omicron variant. The Omicron variant had a milder presentation and was less pathogenic. Strangely, every wave seemed to affect different systems of the body with this reaction. And these kind of reactions tend to be very tissue specific, the allergic reactions. In the first wave, it affected the lungs. In the second wave, we had the gastrointestinal tract that was affected. And in the third wave, seeing that it was type 3, we started to have the microemboli and the clotting issues that showed up with strokes and heart attacks and sudden pulmonary emboli. So in the fourth Omicron wave, the only system that didn't seem to be touched was the neurologic system. And so I suspected, understanding that this was an engineered virus, that the mutation would probably lead to the spike protein being more neurotropic. And we saw that in the Omicron variant. In the second phase of the illness, we saw neuropathy rearing its head. Of course, with a lot of patients, it remained on the 8th day. I have personal experience of that. Finding on the 8th day of Omicron, I lost my smell and developed neuropathy. The strange thing about the neuropathy in Omicron was that it seemed to target scar tissue. So patients that had previous neuropathic illness, root ganglion problems like sciatica, those kind of things, they had resolved completely. But when they got Omicron, those exact symptoms came back. And of course, in treating it again, recovery will dictate the kind of underlying pathology. And those patients with neuropathy never responded to any kind of treatment for neuropathy. Tricyclic antidepressants or anti-epileptics never worked. But strangely, when you put them onto antihistamines and medication that would stabilize mast cells and deal with the chemical mediators, the neuropathy subsided very rapidly. And so that showed that there's likely to be a mast cell degranulation once again in the production of this neuralgia, and the mast cells seem to be attracted to previous scar tissue in the nerves itself. We also saw with Omicron that there was poor natural immunity. That poor natural immunity allowed people to get repeatedly infected with Omicron. And so Omicron was a completely different variant. In the first 3 waves, with all the patients that I saw, I've never seen a patient infected in one of those 3 waves get infected by a subsequent wave. So it looked like whether you were infected in the first, second, or third wave, you had robust immunity to those 3 variants. However, with Omicron, irrespective of your previous immunity, people were getting Omicron over and over. And I think the immune response was already targeting the 3 more severe variants and couldn't prevent Omicron with a change in its motive. We know about the super antigen theory. The super antigen was found in the first, second, and third waves, with the Delta variant being the last. With the change to Omicron, the super antigen was no more on the spike protein, and we saw a different presentation and a different toxicity to this to the virus itself. And now move on to the understanding of long COVID in that understanding of pathophysiology. This did not occur in patients with early aggressive treatment. So when patients were caught very early on the 8th day, aggressively treated and symptoms subsided, they never went on to develop these long COVID symptoms. And so I was under the impression that long COVID is a moderate allergic process left untreated, and it's not aggressive enough to kill the host, but not mild enough to be self-limiting. We saw a wide diversity of symptoms and systems affected with long COVID, from the neurologic to the cardiovascular, to the gastrointestinal and the respiratory. And remember that mast cells are widely distributed throughout your body, and they're the most diversely abundant cell. And so I was of the opinion that by leaving this long process unchecked, it will lead to a mast cell activation kind of syndrome, leading to a very persistent cyclical waxing and waning of the chemokine mediators. The therapeutic interventions for long COVID for myself stemmed from that understanding, and the same leukotriene inhibitors, mast cell stabilizers, platelet activating factor inhibitors, antihistamines, and the steroids were vitally important. But in this case, because of the long duration of the illness, the steroids needed to be milder, but of a prolonged period that you needed to expose the patient to reverse the kind of reaction that we saw. So the understanding of long COVID is as a mast cell activation syndrome causing chronic mast cell degranulation. And if you address those mediators that are expelled by these mast cells, you can get good symptomatic relief from the patient. And hopefully, if the reaction is not too long, then you can actually get the patient back to good health without injury. The longer you leave these reactions, you get unusual immune responses, like certain autoimmune conditions will start to rear their head because of cross-reaction and the constant bombardment of the immune system with these chemical mediators. From that understanding of spike protein and its antigenic nature and toxicity, I was against the vaccine from the start. I understood that spike protein is the primary pathogen of COVID illness, and the illness that I was seeing was more about a pathogenic protein rather than any virulent virus. All patients recovered in that first wave or first phase, so I expected there to be good immune response. Unfortunately, that didn't show with Omicron. With the mandated modified messenger RNA injections, I understand the antigenic nature of spike protein, and we found that post-vaccination, there were a lot of patients 7 to 10 days after taking the jab presented with what was COVID illness. They tested positive for COVID, but I was under the impression this isn't COVID. I felt that they had completely skipped the viral phase and had gone directly to a spike protein reaction. I think it took 7 to 10 days for the body to start to make the spike protein, reach a tipping point as in dosage. And so people started to react. Those that were allergic, like in the other waves, presented with severe illness. Some tended towards anaphylactic kind of reactions, and we're well aware of the anaphylactic reactions we had with the vaccines very close post-vaccination. And it was dubious that the powers that be looked at vaccination, and you couldn't consider a patient vaccinated till a prolonged period after vaccination, which made all the anaphylactic reactions and COVID cases post-vaccination be classified as unvaccinated COVID infections, and of course, COVID deaths. So I think that was a manipulation of statistics and should have been looked at. Now with the vaccinations, besides the immediate immune responses that we see from the exposure to spike protein, we also are becoming aware of its toxicities, spike protein being a very complex protein with prion-like motifs, GP120, certain factors that inhibit certain enzymes in your DNA that help with repair. So we're going to see a vast array of different clinical presentations. And of course, we need to understand why those occur and in which population they would occur. I think there is a genetic predisposition to spike protein and the way it will infect certain people. The strange thing about the way it's presented clinically in the illness itself, in each of the variants affected different systems in the body. And I live in a very multicultural part of the world. In the first wave, I only saw Black patients of Black origin, African origin, and very few patients, or absolutely none of the other race groups. In the second beta variant that we had in South Africa, it tended to affect more, the beta and delta waves tended to affect more the Indian population of Indian descent, the delta wave more to Muslim and Caucasian populations. And of course, there's investigation showing that the propensity might have been towards blood groups. So I think the HLA system needs to be looked at and see if there's any propensity there that might give us some understanding of the spike protein and its propensity to cause certain kinds of reactions in certain kinds of genetically predisposed patients. When the messenger RNA vaccines came into play, we heard about the clots, so I took the opportunity to do some live blood analysis, and I noticed the stacking that was there. Very, very distinctively. And of course, there were tubular structures that look like parasites. Of course, nobody could identify them. I sent samples to vets to identify. No one knew what it was. And then with the understanding of the stacking that might lead to coagulation, I tried different treatment approaches with the repeat blood analysis to see if anything made a difference. Working with Dr. De Mello in India, I tried colchicine. And that was one drug that showed a sudden change in the pattern of stacking. The cells went from stacking and started forming sheets, a polyhedral type of formation with platelet involvement. And that is a preamble to a clot. So immediately I withdrew the colchicine and the picture seemed to go from that back to stacking. So the intervention wasn't complete. And so I thought I need something to stop the platelet activity. And so I tried a combination of colchicine and aspirin. And in that combination, we found that it went back to the stacking was subsiding and there was no clots. So to this day, that is my intervention for patients who have vaccine injuries to prevent microemboli and clots that I've seen. Unfortunately, with the vaccines, as we've seen with the other speakers, we're dealing with the lipid nanotechnology and its consequences. Also, there are many other issues with this vaccine, like the prions, like the fragmented messenger RNAs that will result in many diverse long-term injuries to a large proportion of the population that will go undiagnosed for a pretty long time till it manifests clinically, and that might be too late. So I think the research that is being done is vitally important, and vitally important for me as a clinician to understand the underlying pathophysiology and come up with treatment modalities that might assist my patients. In conclusion, there's a good understanding of the suppression of antigenic nature of spike with the drug treatments that we have, addressing it as a mast cell activation syndrome and trying to clear that away or suppress that kind of reaction. If that reaction is not suppressed, I'm sure we're going to see a lot of autoimmune conditions where the body starts attacking itself And that will be dependent on where the spike protein is made in the body and which tissues are affected. With the super antigen theory, we can clearly see that in the first 3 waves, we had a very virulent virus. And of course, the super antigen was present in the mutations of the spike protein in those 3 variants. In the Omicron variant, the super antigen was eliminated. And so the lack of virulence in that Omicron variant, it looked to come from a completely different lineage altogether. The research into the injection effects and the medical countermeasures to avoid the injury are of vital importance if we're going to turn what has occurred around. And I think to understand where we are, I think there's a need to call a halt to all the biotechnology research until the rules of engagement are well in place. I think, Philip, that's what I've been through, and I'm hoping to get more information from the conference so that I can be of greater benefit to my patients.
This is some big stuff, Shankara, and I guess from a clinical point of view, I mean, the science is almost overwhelming, the kinds of things that could occur. Now, I say could because it doesn't mean that it has to occur. But I think on balance, based on the trajectory of illness that we've been seeing across the world, this looks as though it's the start of a very... What are your thoughts on that?
Where we've turned natural physiology on its head. We've introduced a foreign protein into the body. Especially a protein with so many motifs, with such a wide, diverse toxicology to it. And of course, there seems to be a genetic predisposition to how it acts from looking at the first 4 waves. Christy just mentioned the charges on certain platelets, on certain cells in the body that make it prone for the AstraZeneca vaccine to cause clots. So yes, we're looking at a genetic predisposition, and I think in the design of this, that was the underlying feature, that you must have a target population when you design a bio. And of course, you do get blowback from it, and you got to know who you're trying to infect, and that's the beauty of bioweaponry. It's very discreet in who it actually injures. So yeah, I think we'll crack the code. I think at the end of the day, if you understand what the agenda is, we'll find ways with the different sciences to come together and figure this out.
Yeah, George, have any questions?
Yeah, first of all, I want to say something. Thank you so much, Shankara, for all the work we've been doing together also. And I want to emphasize one more time that there have been millions of deaths through COVID, acute COVID infections, and the worsening in the, let's say, in the respiratory conditions, and people dying miserably on the respirators. And Shankara could prove very early in the pandemic that it's possible just simply with antihistamines and mast cell stabilizers and some other interventions to completely stop that. And so this is something that needs to be repeated and emphasized again and again. And of course, we are now seeing more waves of other variants to come. And I think that was my question to Shankara. Do you think that even though maybe the super antigen has disappeared in these variants that we see right now, there still might be a very prevalent or hypersensitivity reaction manifesting in other organ regions and leading to, for example, disorders in the central nervous system or in other parts of the body? And wouldn't it be prudent for any medical professional to use antihistamines and mast cell stabilizers in every acute infection?
Welcome, yes. Even with Omicron, we're seeing in some patients the onset of symptoms on the 8th day. I personally had Omicron. I thought it was an ordinary sinus infection. On the 8th day, when I lost my smell, I realized it was Omicron. The very same day, I developed pain in my spine. I have a mild injury on my spine that never required any treatment. Unfortunately, doctors are the worst patients, and I didn't use my own intervention to treat that neuropathy. But after 2 weeks of struggle, my patients brought it to my attention that they had the same and recovered when they had it. So I had tried everything. I tried even opiates to try and get rid of the pain. I was struggling. Nothing worked. And then eventually I decided to take my intervention. I took my antihistamines and montelukast and a short course of steroids. And within a period of a few hours, the pain had subsided. And I realized that, yeah, it was a mast cell degranulation on the scar tissue around the nerve. And of course, there's research that's come out that show that antihistamines are showing some potential in remyelination of certain illnesses. So I think research needs to go in that direction to understand that. That's vitally important. And as well, the intervention, I think, needs to be understood by doctors so that we can save patients. When you talk about the reversal of the respiratory problems that we had, Joachim, I trained ICU specialists in Meghalaya. And after 2 weeks, I got a response back from the ICU say that they've managed to, using the intervention, negate 3 out of 4 ventilation. And they called me back to actually treat the rural doctors so that patients don't have to get into hospital in the first place. So I think, yes, it's all anecdotal, but people are alive. And well, I don't have the time to research it and publish it, but yeah, I've got 14,000 patients that are still alive.
Excellent, excellent. I'm going to have to move us on, but Shankara, you'll be there when we're having the open discussion. So we're going to be bringing on our final speaker, Dr. Abdul Manan Bag from Pakistan, who will be sharing with us a lot more with regards to neuro-COVID and the related symptoms. Just making sure your microphone is on. Manan, can you hear us?
Yeah, can you hear me?
Yes, we're hearing you. Wonderful. Great. Glad to hear you. So I'll ask you, Manan, if you could just do an introduction of yourself first, 30 seconds to a minute, and then I will bring up your slides for you to then go through them.
Okay, can you just get it, the latest one on your email? Yeah.
I've got the latest one. I think I've got it prepped for you.
Okay, good, good. So my name is Abdul Manan Beg. I'm from Pakistan, Karachi, Pakistan. I was previously associated with Khan University. Now I'm going to be joining St. George's Hospital in Germany, Bad Aibling, on the 1st of September. Much of my work previously has been focused on neuro-COVID and with different collaborative groups. Okay, we are working on not only neuro-COVID, but also on the coagulopathy, thrombi, and the lymphocytic manifestation of SARS-CoV-2. So I will begin my presentation with the slide number 1, in which I will talk about how many pathways affected by the virus need the treatment. Concerns, neurological issues are there. Okay, we need to develop very effective antivirals so that we can address the residual virus and viral reactivation thing. And of course, the pro-thrombotic state, which is associated with it. So I move to my next slide, in which you will see we talk about neuro-COVID and its diagnostic significance of different modalities, which we take an approach to diagnose neuro-COVID. Next slide, please. So here you see one slide which actually summarizes many of the manifestation of COVID and long COVID. You get the infection through nose, but then it can ascend up through the cribriform plate here, and the diagram labeled A. It does enters the mouth and also the sinuses and the lung. But the most neglected part is the access of the virus to the brain via the cribriform plate, exactly at the tip of the pointer here. Now, it was a hypothesis at first in 2020 when I published a paper, and I alerted my peers and the healthcare providers that it could be affecting the brain very early in the course of the disease, causing direct cellular injury to the neurons, also inciting inflammation that drives the microglia, and in long term, as you can see in B2, can encourage the formation of amyloid deposits and present as a neurological disease, which now is getting all of the attention that it actually deserves. Because if the brain is affected, you can fairly understand that almost all the organs of the body would be secondarily symptomatic. Now, the long COVID part is interesting, and we started addressing this disease early in 2020, late in 2020 and early in 2021. Here you can see in the diagram A2, excuse me, that the brain fog, okay, the dizziness, and the list of the symptoms that you see here are related to the persistence of the virus at or around the brain, causing neuroinflammation, which have been documented here in diagram C, that the virus is capable of taking it along with it, okay, for months to years, okay, causing that inflammatory damage, as is visible in the diagram C. We'll talk briefly about, though it's the turn is on Sunday, that is tomorrow. We'll talk about little role of these anti-inflammatory and other nutraceuticals and as well as neural stem cell therapy to be enforced in clinical trials so that we can have an answer for the long COVID. Next slide, please. Okay, so here comes some of the speakers earlier have talked about it. I will be very quick on those slides where descriptions have been made, but I want your attention here that we were discussing it with Kevin and other speakers that they have got substitution here. Okay, in the wild virus, there were two amino acids which were replaced by the two prolines. Okay, we call it the infamous two proline substitution, and this was done. I was listening to that part of the talk when it was being presented. This was done only with the intention of paralyzing the interaction of this protein with the ACE2 receptor so that the S1 and S2 subunit cannot be cleaved here, and fixing it in the prefusion state would actually mean that this protein would not enter inside the cell. Just after knowing this and the proline substitution thing, two things straight away came into my mind that I want to share with you. Number one, why do a proline substitution? Okay, if you are just injecting a protein or an mRNA that you want to make the body synthesize of the spike protein. So the two proline, the answer of this, okay, to the from the manufacturers is that we made this substitution that we didn't want this protein to enter inside the cell after being cleaved by TMPRS when it sets on ACE2 receptor. Okay, so I was a bit surprised. I've got a question. If you think that the vaccine is going to form a protein, why are you thinking that that protein would enter inside the cell? Because your intention was to immunize the body against this protein, isn't it? For which it's present in the blood or the serum was enough. Okay, if you say that we did these two protein substitution, and keep in mind, please, I'm not talking about the virus, I'm talking about the vaccine. The vaccine X has to produce a protein. That protein should have two protein substitution, they say, so that the protein should not enter inside the cell by cleavage at S1 and S2 site. So it actually freezes the protein in the prefusion state. So my question is, why there was a fear? We didn't have this fear with polio vaccine, HBV vaccine, HCV vaccine. Why do you think that protein synthesized as a result of a vaccine would enter inside the cell? I'll tell you something. They knew it ahead of time that this protein is toxic. It can enter inside the cell, cause the cell damage, and that's the reason they say the two protein substitution was necessary. Okay, so what did you do for the furin cleavage site? Okay, so everybody talked about its insert. So nothing was done for it because they knew that eventually, like it or not, the protein would enter inside the cell by using the furin cleavage site on it, okay, which is very well preserved in those vaccine resultant proteins which have got two protein substitution. And when guys like me and my peers made noise, okay, that what about furin cleavage site? They also made two substitutions here as well. Okay, so my next slide will show you how many receptors it actually uses to enter inside the cell. So you did something for ACE2, very good, brilliant, but you don't have an answer for why you were afraid that the protein would enter inside the cell, only because you already knew that it would enter inside the cell and could be toxic to the cell. Okay, so then comes the other receptor, TMPRS, the furin site. Okay, if you make a vaccine, okay, which also mutates that, what about all the other receptors here, okay, shown in stars and non-stars, like CD147, okay, DPP4, CD13, and I'll tell you, this is not a homemade protein, okay, I didn't make this slide at my home. There are at least 7 papers published on each of this protein very well documented that in very famous journals, okay, which have got a rigorous peer review, that these receptors are also used by the virus to enter inside the cell. So that protein, okay, which results from the which results as a consequence of the vaccine, could also use NRP1, ADAM17, okay, GP41, and this is only what we know. The number of these receptors have grown from 13 to 21, okay, in last year, and last I checked, okay, it was 22nd receptor, again jumping and showing that the protein is capable of entering inside the cell. So there was something fishy. They knew that this protein would enter inside the cell and cause all those mischievous effects of it that we know. Next slide, please. So here I show you that, and you could ask me, okay, is there any evidence that this protein persists in the body after vaccination? So this is a very renowned journal, Clinical Research in Cardiology. It says autopsy-based histopathological characterization of myocarditis and after anti-SARS-CoV-2 vaccination. This paper, okay, was under a very rigorous peer review by 5 reviewers, if I'm not wrong, and then they showed the presence of lymphocytes in the midst of the myocardium where they cause the damage. So next slide, please. So this is the evidence that there was a problem with the protein that was resulting from the vaccination. Okay, so what novel thing we did, and with my team, with Joachim and other what you call as collaborators, we have got this paper under review, where just like Hammerstrom and publications, okay, have shown that the neutrophil elastase can split the spike protein. Theoretically, here we show that this spike protein, if splitted by neutrophil elastase or other proteolytic enzyme, can break into small pieces like these. And these are the pieces of that spike protein that they call amyloid-like or amyloidogenic protein. Okay, so I came up with this thing that, okay, let's put the sequence of human amyloid precursor protein, here shown as A4, red arrow, and let's compare the sequence with S1 protein in the SARS-CoV-2, or the one that results from the vaccination. And all the solid bars you see here in the midst are identical position, the double dot similarities, and you just see the sequence. I don't say they are just like amyloid precursor protein, but see the number of the stacks and the dots, okay, here, particularly in this sequence, okay, where the spike protein is ranging from 371 to 420. And I took this screenshot, okay, when one of our presenters was actually showing the presence of those amoeba-like stacks of the amyloid, and these small segments or these small fibrils that you see on the red arrows could be representing these sequences. Now this paper is under review, and I asked a question, okay, for which a reply came from Kevin that theoretically these are the same amyloid proteins, okay, which are, or amyloidogenic protein, which are causing the clotting problems. So you can see, we don't call it amyloid protein, we call it amyloidogenic or amyloid-like peptide. Hammerstrom has documented it. Okay, we have got a sequence ranging which comes from these amino acid, which is shown here. This paper is under review. Okay, we get all the listeners a PDF copy once we get it published. Next slide, please. Okay, so here comes all the media attention that young athletes are dying due to vaccinations, and the spike protein is being overproduced in some of them. You heard Shankara that early in 2021, we were the one who were making noise on Twitter and everywhere that do some HLA mapping or see that who specifically are predisposed to develop excessive production of spike protein even after the 7th day of getting the jab. So that part is not being funded. Okay, so very sorry to say, because it's not in the interest of the bigger pharma, you know. So, but I'm a solid believer that the guys who overproduce this protein would get an immunological reaction to it, and the adhesiveness of that nanoparticle that you heard with the earlier presentations, okay, with platelet, is going to invite all this trouble that is still going on. Next slide, please. Okay, so this is a very complex cascade. I won't walk you through all of it, okay? I just want you to focus on one thing. the spike protein itself is capable of causing endothelial injury. With or without these yellow antibodies, okay, if it damages the endothelium, okay, you need not do anything. The rest of the formation of a thrombus is a biological, physiological process. So the S1 protein, with or without the antibody, damaging the endothelium and the glycocalyx layer of it. Once you damage it, okay, your body is programmed to produce a intravascular mass made up of platelet and fibrinogen. We call it the thrombus. And this thrombus can obstruct any artery, giving you a heart attack, a stroke, you name it, gangrene or whatever you like. Again, the neutrophil is there, you see. Again, the mast cell is there, you see, releases cytokine, which can excite the coagulation sequence. And this clot buildup, okay, can obstruct a blood vessel enough to cause damage to the tissue, which you are seeing on daily basis in cases of long COVID patients and patients with jab injuries. So if the protein is being produced continuously, like it happens with some individuals, for which we didn't have any precautions or any genetic mapping or any HLA segregation, the story would go on. Keep on vaccinating. You will get more and more patients, okay, with a particular HLA configuration who would develop the thrombotic complication. Next, please. Now, this slide shows you that how and what mysterious places the spike protein can go and it can get deposited. Skull meninges, brain axis, you see here, okay, is being 60% of the patients who were infected with SARS-CoV-2, okay, actually showed the presence of it. Well published in a very reputable journal. Next slide, please. Here you can see the skull and meninges, they accumulate enormous amount of spike. And sometimes you wonder, okay, why these patients do say we get a heaviness here on the forehead and the head. It feels like a pressure. You tell me, if an inflammation is going on in meninges and the skull, what else the patient would feel? So this paper demonstrated very clearly that there are collections of spike protein and its deposition in the skull meninges junctions, which explains the head pressures and the brain fog in many of the long COVID patients, okay, and many of the patients who are affected by the vaccine. Next slide, please. This we show you that the regions which earlier speakers talked about, where parahippocampal gyrus, orbitofrontal cortex, okay, they actually accumulate this protein even after a long-term infection, like in long COVID, okay, and these are the primary sites of deposition of that spike protein and SARS-CoV-2. And again, I would emphasize they take this route shortcut, okay, no blood-brain barrier, go to the brain and do the trick. While we keep on searching it in the blood and the nose by PCR, okay, it's already enjoying a dinner there in the brain with all the damages that we know it can do. Next slide, please. Okay, this study was one remarkable addition to science, where they showed that people who were infected with SARS-CoV-2 have had a remarkable shrinkage of the cortices, and their brain mass shrunk. Oxford group of researchers. Next slide, please. Actually, very well demonstrated the presence of the shrinkage of the brain volume in many subjects who suffered after SARS-CoV-2 infection. Next slide, please. In this one, we show you that there is a similarity in between those sequences and amyloid Alzheimer's disease. You see, in the Alzheimer's disease here, you can see these star-like sparkling pink dots. Just try to spot me a difference when the SARS-CoV-2 does the same in the brain. Look at this. Look at this. And the morphology is astonishing. I mean, and the composition would be revealed in a very short time, that whether they are made up of the same sequences or small segments, okay, of sequences which actually resembles the small segment of the sequence of beta amyloid, and then overlapped, okay, the Alzheimer's disease with SARS-CoV-2. You can see that you cannot actually say that there is a difference. Okay, this fiber is the morphology is like astonishingly similar, if not identical. Next, please. Okay, so this is the same paper that actually was. This paper will show you the beta amyloid interaction with fibrinogen, which is a novel, what you call as thought, and they proved it. In the next slide, you will see that you just see here what they said. They showed that the amyloid beta 42 fibrinogen oligos were found here, and this amyloid beta 42 actually is a driver of the fibrinogen. Okay, both of them shake hand to cause the deposition here in the brain and also in the blood. Who knows? I mean, like if they are doing the same in the blood, okay, just count those platelets to be aggregated here, okay, and form those intravascular mass. And with liposome and what was explained earlier with the nanoparticles, if they have got a charge that can attract the platelet, you cause a buildup of mass, and the thrombus grows bigger, and the organ can say goodbye. You know, so I see a very ominous interaction between amyloid beta 42 and fibrinogen oligomers here. Next, please. Okay, so it's about tomorrow, but then my question, you remove it. I mean, like, so there have been well documented papers, okay, that show that drugs like melatonin and resveratrol, okay, they actually prevent the neurological disorder and also have been implicated in treatment. Next slide, please. So melatonin, I just mentioned in the previous one. You will see some of the slides now showing some effective use of melatonin that was published here. Next slide, please. Okay, again, this one is showing that it can, melatonin can remarkably increase the glial lymphatic clearance, I mean, the flow during a sleep or of the patient, and clear those amyloid pro-amyloidogenic beta peptides, so that the deposition in the brain becomes less and less with time. Me and Jotham have personal experience of this melatonin being given to a 75 plus year old female, okay, in whom the deposition was remarkably reduced with melatonin alone. Added with other antioxidants that I will show you in the next slide, you will see that clearance becomes very much possible. One more paper showing the same. Okay. So we talked about this earlier, that the nasal route is one route, okay, by which the virus can enter the brain and cause deposition of spike protein short peptides, leading to Alzheimer's and stuff. We published this. We alerted this very early in 2021. Next slide, please. Okay, so the medicinals and the health shield, what you call as pharmaceutical production are involved now very actively, and it's nearly about to be launched, okay, as the patented. This combination, you will come to know, has got ingredients which can clear the CSF and the brain of those beta amyloid that we were talking in the beginning of this conference today. So if it has got melatonin, resveratrol in it, okay, and other components which can clear up those peptides, that's the answer to a long-lasting what you call as amyloid mediated Alzheimer's, or the pro-Alzheimer's patient, as I call them. Because you like it or not, almost all of the patients who have got deposits of these amyloid, it's just a matter of time, will turn into Alzheimer-like patient. Okay, next slide, please. So you see, here I'm showing you some papers that actually came as a result of a collaboration with Health Shield and medicinals, okay, which are now available for free download at ResearchGate. And why I say medicinal has got that power to do it, okay, is the next slide we will show you. It addresses the cascade sequence. How? By stabilizing the endothelium, fixing the glycocalyx, okay, entangling the portions of the spike protein which actually sits over the endothelium to cause the damage. So if you just prevent the ignition part, the rest of the effects are just like a consequence. So you will never find more than 5 papers mentioning glycocalyx and endothelial injury being the prime driving force. Everybody is talking about the microclots and their removal and stuff. I mean, like, why not prevent their initiation? Once you get that going in combination with help of FRSs, that would be a very brilliant combination, okay, to try on patients with long COVID, or affected by vaccine injury, as is now being reported by guys in Germany and worldwide, okay, who are combining health FRSs with these natural products and molecules to prevent the glycocalyx damage and damage to the endothelium. So if you prevent this, the rest of the formation of the microclot, you call it, or thrombi, gets decreased itself. You don't have to go and kill the clot. I mean, fibrinolytic system is incapable of doing that, but some of the components of medicinals can. I'll show you how. Next slide, please. So you see, this is evidence is when you taste the pudding, isn't it? So what does this bottle contain? Viclin, yes. Quercetin, yes. Asparagine, yes. Curcumin, yes. Piperine, yes. And then even more than that, because it says 9. What are the stars here? 1, 2, 3, 4, and only 5. And people have published on these molecules in these reputable journals that you can see on the right-hand side. So I think that it's only a matter of time when we will realize that these agents in combination, okay, do wonders compared to when they are given alone. Next slide. I'm left with I think three slides more, or 2 slides. And do you think that NIH was stupid enough to actually try these molecules in their clinical trials? Okay, they shared the result with us, individual molecules, but then they showed very effectiveness again, very highly effectiveness and efficacy against COVID. And now in long COVID, they are under trial in the next 3 months. So if the preparation has got a combination of them, just imagine the drug synergism that it can offer. While the NIH is doing it alone on asparagine, piperine, and stuff, if you have a combination of 6 or 7 of them, it does the trick. Next slide, please. I think.
I think that's the last one.
Okay, this is the last one. So if you have got any questions, okay, please ask it here. Give me a DM, okay, and ask for anything that actually you think is dubious, okay. It's my pleasure to work with groups, okay, who are productive and who actually can give an answer to the questions, okay, that we are longer waiting for. Thank you very much.
Wonderful. Thank you, Manan. Well, let me ask the first question with regards to that, because I've been looking at neurodegenerative brain diseases for many, many years. Mm-hmm. One of the biggest challenges is, even if you identify what the problem is, say, for instance, even with Alzheimer's, to reverse it is extremely difficult. Is there any way that the damage can be largely prevented from occurring, especially because it seems to be immune-mediated and ongoing process?
Philip, the thing is that if you can suppress the neuroinflammation, okay, by any way, okay, you will prevent it. If the deposition is already ongoing, okay, drugs like melatonin, resveratrol, okay, and vitamin E in form of liposome or without liposome. I mean, there are molecules which are known to remove those amyloid, okay, well before COVID-19. Now, if COVID is causing the deposition, why search an answer in a novel drug which will take 25 years to come into the market? Okay? Why not use drugs which are already well documented, I mean, have got a reputation, over 75 papers published on them, they clear them a lot. So the only question is how do we give it? You give it intravenous, okay, you sit for a year, okay, nothing is going to happen. You know why? Because there is a barrier known as blood-brain barrier. You give it through nose in the form of a spray, it goes through the cribriform plate, directly no CSF blood barrier here, okay, no blood-brain barrier here. You can search the PubMed for this area lacking the blood-brain barrier. Melatonin enters and it does the sweep. So there are answers, but then my question is the world prepared, and those big pharma guys are prepared to look into it? I mean, like, if they want to, they will see the result in coming 2 years, okay, that these substances work wonder. And then they already are doing that, okay? So I think clearing it is an issue, but with known molecules, we can do that.
Go ahead, George, have any questions?
Yeah, I think that we should take this discussion into the roundtable now, because I do have some specific questions to Kevin, because Kevin has worked for decades on the disaggregation of these kind of aggregations in vivo, in live brains. So I think that we should take the discussion up to a broader circle of experts here.
Yes, so wonderful. We've still got everyone with us here. So yes, well, this is, let me just say something at the beginning for everybody. I think it's important for you to note that without a shadow of a doubt, our scientific community here has been very candid with what they have said. As you know, on many social media platforms, you're not allowed to talk about the science in a candid way. So it's very likely that you may not see this in its full on the standard social media platform. So please look out for the links where you'll be able to watch it in full afterwards if you missed parts of it. So let's get into a very candid discussion then. Oh, you want to go first, Joshim?
Yeah, I don't know if I think Kevin is the one that is staying up the latest from all of us, and maybe I can ask him one question that might be relevant for the physicians and for the patients. Now looking at these, let's say, neurodegenerative diseases, and you just heard Manan, and my question was, you once told me like a month ago, even though we disaggregate all these toxic aggregates in the brain, be it brines or be it amyloid tau, alpha-synuclein, TDP-43, you have observed in your practice and work that the neurodegenerative disease would not stop and would continue. And that kind of really knocked me off my chair, because we have been focusing on rendering them non-toxic or disaggregating them in the first place, like all the other pharmaceutical or experts are doing. So what would you say, in your opinion, is the reason for the neurodegenerative disease to continue even after you cleared out these aggregates? You're muted, Kevin. You're muted.
Is that working?
Yeah.
Okay. With respect to the disaggregation and why you still see progression, I think a lot has to do with the fact that just when the stage you're getting patients. So when someone presents with Alzheimer's, they've already gone through the prodromal stages, the ability of the brain and or any organ system, if you're looking at systemic amyloidosis, to respond has been used up. And so when you're essentially, and there's a element that the aggregations may be actually part of a sort of innate immune response to an underlying toxin or epitope in this instance. It might just be the case that you disaggregate them and you're just allowing the original toxin, one of the better expression, to begin to roam freely again. And I just don't think that there's the scientific and basic research understanding of these processes. We're very much constrained by the theoretical frameworks with which we look at these issues. And prior to sort of SARS forcing the issue with respect to long COVID, because so many people were presenting with like this ME/CFS type condition, it could be easily ignored by most doctors, most medical systems. And you know, the sad fact is that even if they agreed that there was something wrong, they'd probably tag you as having some sort of functional neurological disorder, which just means they don't understand what's going on, and they can't do anything. And so it just becomes a matter of symptom treatment.
You know, I just wanted to ask a question here with regards to now, Charles, based on what Kevin has just said there, do you think that this, as you said, that this is probably lab made. Do you think that they actually had the knowledge that these things could occur beforehand? What are your thoughts on that, Charles?
Yes, the fact is that they spent decades researching. They spent billions of dollars just on an HIV database of genomes, just point where they could create that will be ostensibly the point was to create vaccines for HIV. But more than $100 billion has been spent just on research for HIV treatment. And no, obviously, there's been no successful vaccine, but they do have this massive database, and they have this understanding of these epitopes. Thousands of scientific papers. Now, they may not have, I don't think they know exactly how everything works. But from the perspective of a bioweapon that is incapacitating, all you have to do is just basically throw a bunch of stuff at the wall and see what sticks. So I believe that's what's happening here.
I just wanted to bring in Christy on that, because as you can see, Christy, there have been multiple layers of discussions about the characteristics of the spike protein, but you actually are focused really on the lipid nanoparticle. Now, when you heard the discussions about the spike protein, can you see that interaction with the lipid nanoparticle being almost off the scale frightening?
Thanks for asking. Absolutely. And I just wanted to comment that position that I've held over the last few years has been working with recombinant proteins. And when we talk about the RNA entering the human body and the human body producing a protein from that, that's recombinant. And oftentimes in the lab, just a sidestep for this moment here, that when you make a recombinant protein, even if it's not the spike protein in a lab, in cells where you introduce RNA and lipid without even any kind of protein substitution, it's not uncommon for those proteins to misfold. So this would happen with other kinds of pharmaceuticals that are developed, and what I've developed was only for people with genetic disease or cancer, not for people who are healthy. But when you talked about the RNA and the lipid nanoparticle, absolutely, with what's happening with the current injections, with especially the recent study that I've provided the slides for with more details, where the positively charged lipid is mutating the RNA, it's causing a point mutation base pair. It would cause amyloid, the same things that Dr. McCarran, Dr. Begg, and Dr. Shetty, everyone that has spoken about. But also there's water in the center of the LNP that is breaking the RNA in addition to that. So you've got again, that was spoken about with the other presentations and doctors, and thank you, where you would look at non-coding pieces of RNA, and those have been shown to be oncogenic in studies. So it's just a nightmare. It's just a phantasmagoria of concerns that you could have. Like I don't even think we know the full consequences of what we're even seeing now, especially, Dr. Shetty too said, down the road, 3 to 5 years, what are we going to see? Because what we see now is just what's being tested.
Wow. And so that brings me to Shankara. When we look at this, I sometimes, quite frankly, wonder about almost the triage approach to medicine, meaning that if this is occurring and this many people are affected, the truth is that you are unlikely to reverse a process that has already started. You're better off protecting someone where the process hasn't really occurred as yet. It's kind of like what happens on a battlefield. Is this where we're heading?
I think you're absolutely right, Philip. There's certain of the processes we don't understand, and we know that they will cause injury and death. It's unfortunate, but I guess the more understanding we have, and look, in any technology, I think it's the way it's used and regulated. And unfortunately, these technologies have been used for nefarious means. So we can actually use them to solve the problem if we use them in the right way. So I think we need to turn the tide and understand the injuries. And once we go down that road, we can use the different technologies. There's a whole great extent of medical systems that have been left behind by allopathy and the capturing of allopathic medicine. And I think if we broaden our horizons and look at all the different medical inventions from bioresonance to Ayurveda to all the nutraceuticals, we'll find solutions. Our understanding is still very limited of nature and physiologic systems. So I'm sure something will pop up in the future to help us solve the problem. We just got to
I'd love to hear Manan's thought on the same question. What are your thoughts, Manan? Is it that there may be some that can't be fixed?
I'll tell you the candid and the honest answer. They taught me in medical science that there are 3 types of tissues. Labile, which keep on regenerating. You damage them, they regenerate. Number 1. Number 2, stable. They don't regenerate often till you injure them. And the third one is the dangerous one, the permanent one, which never regenerates. Okay, neuron, number 1, myocardium, skeletal muscle, adrenal medulla. So if there is a damage to these 4, okay, say a goodbye. I mean, like even a neural cell transplant or neural stem cell transplantation, until and unless it is done spot on the same place where the loss is, you cannot repair it. To some, okay, it would appear that I'm very pessimistic, but it's a medical fact. You cannot replace a neuron in parahippocampal gyrus, or you cannot replace it in the dorsal vagal nucleus, until unless you go and implant those stem cells there. Now, some guys are being fooled by given umbilical stem cells, okay, intravenously, intrathecally, okay. One of my patients, okay, online, who consults me, okay, said that the parents are ready to spend a million, like close to $1 million, okay, on that stem cell therapy. I asked him, okay, I will not name him, but they just say, gentleman X, okay, can you tell me that, can you go ask them, okay, what is the surety that it will go exactly in the cortical part that where the loss is there? How does CSF only makes it swim there? So no, if you have lost a neuron, you're lost a neuron. If you lost a myocardium, you lost a myocardium. If the skeletal muscle is damaged, it's damaged. Liver, pancreas, GIT, not the epithelium, the smooth muscle, they all can regenerate. Okay, if you injure them, they can. The skin is very marvelous, labile tissue. It can regenerate over a period of 7 days. You have seen you fall from a bike, get an abrasion, okay, it gets repaired. It doesn't take time over a period of 3 weeks. But then if you damage a bone marrow, even then there is a replacement possibility, because bone marrow actually is a heaven of replicating cells which are genetically programmed to replicate. But skeletal muscle, myocardial tissue, neuron, adrenal medulla, once damaged, they are like diamonds. They are forever. No coming back. Okay.
And Joachim, you've been working a lot with the nutraceuticals. Have you had a lot of pushback with regards to that research? Because it's, not heavyweight biotech pharma stuff. Or what has your experience in the touching this industry been?
Yeah, I mean, to just give you an overview, we have not had any headwinds. Actually, what we are doing, we are piggybacking on the research. I mean, we're sitting on, I don't know, tens of thousands of research papers with natural molecules and compounds having undergone in vitro or animal or preclinical or even clinical trials, but they never were transformed into real products. So why did they finance all that? And why did they come up with such good results? I even have a very early SARS-CoV-2 study where they said hesperidin was outperforming all known antivirals on SARS-CoV-2.
Very right.
Concern. Yeah?
Very right.
So what they're doing is so we have no headwinds here. So we are actually now very happy that we have access to all these kind of publications. And the only shortcoming is with nutraceuticals or dietary supplements, where many people just brush them off as some herbal remedies. Yeah. The bioavailability. So given that you can get the bioavailability so that it really works, it can be really a very potent weapon, because it is such a multi-spectrum compounds that can address so many things at the same time, and trust nature. But we haven't had any headwind. No, it's all fine.
I want to throw this comment out into the group and see if anybody wants to take it on, because we're all scientists and science has taken a huge hit recently. And this is a question. Hope you can all bring back the trust in science. Keep moving forward. Thank you all. How in the world is the scientific community going to recover from the fallout from this? I mean, anyone want to take that on?
I mean, I've thought about this a lot, and I think one of the major issues that we have is just that we thought the market could fix anything, right? We just basically allowed the markets to go in and induce a bunch of perverse incentives in institutions that were bequeathed to us that should have been there to protect us and have some degree of objectivity and not subject to being pushed around by corporations, etc. What I would do is I would try to restore the academies. I would absolutely prohibit anyone who wanted to have a laboratory, be a PI, professor in a university. You should be prohibited from stocks, all this type of thing. All research. I'd abolish the journal system. I'd just make it such that each department submits a bunch of reports with respect to the studies that they've done and the results that they've done, and then blockchain it and have it such that it's free to access for everyone. And then, you know, the stuff that's good and repeatable, that will eventually rise to the top. But right now, we've completely broken the system.
Yeah. Very right.
Philip, I think as well, we talk about regaining trust in the medical and scientific community. I don't think it's about regaining trust. I think it's about redefining who the true medical and scientific community is.
Mm. Yeah, that's profound. Yeah. I mean, this is
we will have to keep these scientific candid, hardcore science away from funding coming from the big pharma. You know, because if you use their money, then they actually say we want this results, and that happened with vaccine. That happened with so many other drugs, which we have been using for dementia and Alzheimer's for 20 years now. And then comes the test that, all was funded by Big Pharma. The reason we actually had to accelerate the trial, change the result. It's not easy for us to get the public confidence back into us, very soon. But with time, keeping these fundings away, where they get a chance to say something on the final product, science should be very clear and very transparent. You know, it should not be influenced by who is funding it, who wants what type of results. And if we keep on doing that, nobody's going to trust us. Ask me how much the public trusts on a scientific paper these days. If I even say it's on PubMed, they say it's a shit box, if it came from a funding coming from a big pharma, or guys wanted this particular result. I mean, like, look at this. Joachim was saying, that they tried hesperidin in NIH clinical trial in 2020. Why that drug was not moved forward? Why it kept hanging behind? And only because somebody is not happy that a national molecule comes and actually addresses the disease. You know? So
yeah,
I'll tell you something.
Go ahead, Manan.
Very quickly, believe me, products like honey, products like green tea, products like curcumin, cinnamon, they have got the answer. More than 21 alkaloids, alone in these combinations that can kill the virus effectively, including the ones which have been reported in the past. But nobody promotes them, only because there is no earning in it. Because you get a cinnamon from a shop, you get a green tea from Sainsbury, So why promote a thing, which actually is not benefiting the big company? We will have to regain our trust in public by doing candid science, which is not influenced by the big pharma. That's all.
So I'm going to ask again, Charles, this, because this is a comment that came in, and I'm showing it here because I have wondered this as well. From Gail, My fear is that they have a new virus lined up to distract everyone from the jab damages. You deal with this kind of bio warfare kind of thing. Is that a reasonable perspective, Charles? You're muted at the moment.
I think educating the public is important. And I don't think that they can get away with what they got away with this time. Because across the Rubicon when it comes to this public health stuff, and the public inherently understands across the world that something that this was manipulated, even if they don't understand the exact mechanism, they understand it was manipulated. There are, I think, people have a misunderstanding of what the true threats are when it comes to viruses. Let's say there was an H5N1 crossover event, or well, they say it was natural, but it was actually released. Well, epidemiological dynamics in the real world run into all sorts of problems, and my fear isn't H5N1. There's actually studies that the NIH has suppressed, and some by the same authors who are controlling the narrative now, where they talk about immune imprinting. And so the population, the most likely virus that even Robert Redfield said was H5N1 or H7N9. We're talking about a flu pandemic. In that case, a good portion, a majority of the population would be not necessarily immune, but I think it's less likely that they're going to use viral stuff. My problem, what keeps me up at night, is the fact that COVID-19 has already done damage in the short, medium, and long term as an incapacitating agent, above and beyond, the fear factor of a different virus. COVID-19 ultimately, I think, and the vaccines are going to kill far more people than any H5N1 thing ever should. And so the best thing that we can do is educate the public about what's already happened, because then they'll have the right frame of reference and not put up with this stuff in the future.
Excellent. Any other questions or thoughts from you guys?
I do, please.
Yeah, go ahead, Christy.
This is just jumping off of what Dr. McCairn said with regards to what you asked with restoring trust. As I had to work with a lot of regulatory committees around the world. It wasn't just exclusive to the United States with the project and process design for these biotech projects. We need regulations put back into place. Like we know that Fauci removed the RAC, what is called the Bioethics Regulations Committee that for biosafety for genetic products, and then it was absolved into the NIH. We know that the FDA this year in the United States, or at the end of last year, removed the necessity to do any kind of animal testing for any drug products going forward. We know that there are products that are launched and made it through and are approved, and then other products were fast-tracked without any proper testing. And then when the initial product was retracted or it was found to cause events and pulled, which the secondary product was linked to, they didn't pull anything else out there. So I think that the entire system needs to be redone, not just in the United States. And we need more regulations that were even there previous, like other people have spoken to, like Dr. Manan, like keeping the money out with the FDA being too tied to the companies, but we need more regulations. We need to walk back what was originally in place prior to 2020 and then add on to that, because I don't think the public needs to be made aware. And then I would ask for a call to action. I'm well aware behind the scenes of certain doctors that aren't in this group that are vying for positions in the NIH, CDC, and FDA and the 2024 elections of the United States presidential that's coming, and that people that are promised positions. When you step into those positions, when these presidents get elected, you need to walk back those rules and regulatory agencies to what it was prior, restore what we had, add to it, and put your money where your mouth is if you're going to be on Twitter and tweeting and getting likes. This is very upsetting. People have died, and we're watching all of these things. And unfold and all, it's just getting tied through political lenses, well, then I would expect the people that are speaking out and are about to take positions to do their jobs and to get those regulations back into place. And
Very
thank
right.
you for everybody who has given information here too. Thank you so much.
Very right.
Wonderful, wonderful. Yes. Well, I think that's
Philip,
yeah,
I
go
just,
ahead.
I wanted to ask you a question, actually. You're the autoimmune specialist. Maybe Dr. Chetty could chip in as well. I think we got thrown very much a curveball with this finding. Well, perhaps it was deliberate. Maybe they did know. But the class switching response to IgG4 that we're hearing more and more about. What's your take on that? And is it a serious problem when we're seeing, as Dr. Chetty said, where reinfection is occurring now with these circulating variants?
Can I take that one, Shankara? I've recently been talking about this in relation to myocarditis. So I've done a presentation on it. And when I look carefully at this class switching question, what stood out to me is after Manan had made that educated point in a previous discussion about the proline substitutions, when I noticed that there was a couple of strange patterns, was that of all the conditions, the one condition that stood out most with mRNA versus the adenovirus was myocarditis. It occurs far more frequently than the adenovirus vaccines. Almost every other complication seems to be tied to the higher in the adenovirus group. The other bit was that they found that there were circulating free spike proteins in the adolescents who got myocarditis. So that seems to be relevant. And then the third thing is that the IgG4 doesn't really happen with adenovirus vaccines, only primarily with mRNA. So when I put all of that together, my thought is that there are two, I think, amino acids that are really important with making proteins very stable. I think it's glutamine and proline, if I remember rightly. I suspect that when they made the attempts to neutralize the furin cleavage site and the receptor binding domain, they made the protein almost too stable so that it couldn't be properly degraded by the immune system. And if the immune system couldn't degrade it properly, what it would then try and do is tolerate it, because it would then think, okay, it can't degrade this easily, it's going to cause problems. So rather than ongoing inflammatory processes, let's just use IgG4 to stop that process. It will work in the short term, but the question is what happens when the IgG4 levels drop and you still have circulating fragments or spike proteins still remaining, and the immune system is no longer trying to fight the virus. I think the combination of all of that is what I find very, very frightening.
Yeah.
I think, Philip, as well, with the clinical presentations that we saw, we know that the spike protein has a very allergenic nature to it. And so when you talk of allergies, a repeated exposure to an allergen builds tolerance. That is desensitization. Now you got a repeated dose of spike protein with the vaccine. And we saw with the vaccine, it doesn't stop infection, it doesn't stop transmission, but it stops severe illness. That is tolerance to the pathogen, which is the spike protein. So the prevention of severe illness and death was not because of any immunologic benefit that it offered as far as immunity goes. It was benefit in as far as desensitization and tolerance to spike protein. And I expect that at some point, IgG4 is going to show up.
Yeah, go ahead, Mana.
The thing is, you can expect the IgG to come in and actually participate in the flight, okay, without being remaining benign. You know what I mean? Because theoretically, we know the structure of these antibodies, IgG, they have got a Fc portion, and if that Fc portion gets a receptor, doesn't matter. It's an endothelium, it's a myocardium, it's a skeletal muscle, it's a neuron, it's a microglia. The moment the Fc portion of the antibody gets fixed, okay, the complement it activates can render enormous damage. Then it doesn't care which organ it is, you know. And the bad part of the story comes when the SARS-CoV-2 destroys the lymphocyte, causes lymphopenia. Now you're left with nothing, you know. So even if you for a moment forget GP120, you know, actually the person has got acquired immunodeficiency syndrome because he's got no more lymphocytes left there. And there are over 25 papers, including in Nature Publishing Group, which have confirmed the lymphocytopenic property of the virus. And now 2 or 3 papers emerged with the protein as well, less protein as well. So see the magnitude of the damage. I mean, like, I agree with Dave, Charles, you know, that you don't need a new virus, okay? You would take 50 more years to recover from this bloody pandemic and the way it was managed by the vaccines, you know. Those will actually encompass the entire globe. Okay? Just wait and see for in 25 months, you know, you will see everybody is going to get affected, clinics will be full. And did they know the answer of what they did? It's not at all in their domain. Now the S thing has hit the fan. You know what I mean? Now it's spreading everywhere. You know? So yeah. Thank you.
All I wanted to say, so I think now I just wanted to make one statement. I'm going to ask everybody to make a closing statement for me, 1 minute or so. And so, as I said, at this point, you will see that the video has been cut. And you will see the end of this discussion and you will get the last minute. And it's largely because this was an extremely candid, frank scientific discussion. Sadly, on many mainstream media platforms, they don't allow that kind of candid discussion. So what you must do is look for the links where you can see it in full. And I'll ask all of the presenters here to use their platforms as well to share this very fascinating conference. So I'll ask each person in turn. Since Christy's at the top of my screen, I'll just ask Christy last closing comments for today's presentation.
Thank you for hosting this and everything that you and everyone here is doing and outside of this conference to bring awareness. It's a pity that social media is still silencing, especially on Twitter. I think that my last statement is those who are in larger positions on social media need to spread this and other lesser seen videos with more information instead of keeping their blinders up and be more open in what they're talking about, because like Charles said, there's a lot of people driving the conversation out there and they're driving it in the wrong direction. And there's been such amazing information here that needs to get to people that I hope it's shared by larger audiences. I just want to say thanks so much. Thank you.
Wonderful. Manan?
My closing sentence would be to all the listeners, you know, with long COVID and CSF, like please just don't get involved with drugs or molecules that you don't know of. If somebody got benefited from nicotine patches, okay, it's not necessary that you would get benefited. Okay, try to stress over your HLA configuration and in your family, whosoever got affected, so that if we are not even funded, you should know which type of HLA configuration is actually going to bring you the disease. Spread the word, okay, and I want the health regulating authorities to just please help the humanity with the fundings that are needed to do some basic clinical sciences research to come up with molecules, nutraceuticals and stuff, okay, that can revert the long COVID and these chronic illnesses. I'm very thankful to all the participants who came here at different times. At my clock, it's 1 a.m. now, you know, but then these are the ways that we can bring attention to a disease which has been neglected and which is so very prevalent. You know, thank you very much.
Thank you, Manan. And Shankara?
Philip, with the problem we've had so far together with censorship, I think with the mainstream narrative, I'm a proud conspiracy theorist. I think we had more. Shots have been fired. We're waiting for the victims to fall, and we're trying to figure out how to prevent that from happening. We've seen the parallel narrative with the financial sector and education, and there's a lot of things happening in parallel with what's going on with this virus. So I think our duty as critical thinkers are to enlighten the public. And what's going to solve the problem is a healthy dose of faith. So I think we've got to come together and put our heads together. A little bit of faith will solve a lot.
Wonderful. Thank you. And Joachim?
Yes, first of all, thank you all for being there and sharing your incredible knowledge with us. Yeah, so as a final word, with a good reason, this is called silent disaster. So we're having 65 million registered people, already patients affected, and the situation is gradually worsening. So today's conference was more showing what kind of problems we are facing, and tomorrow we will be with all the doctors and experts that are treating patients on a daily basis, as pretty much the only people in that tomorrow's 7 speakers group. And so I want to invite everybody to attend tomorrow's conference at the same time, again, 6 p.m. UK time. Yeah, and thank you so much for your attention.
Wonderful. Thank you. Kevin?
Well, in final passing, I'd just like to say thank you, Philip, for taking the time to organize this, Joachim as well. Everyone here, it was fascinating listening to you all. To people who are listening, I would just say this one thing. It's highly likely that the reason we ended up in this situation was because of biowarfare, medical countermeasures industries. You need to get active in making sure that they're wound back in. And how that's done, I'm not exactly sure, but we have to at least try. And as Chetty said, have faith that we can prevail in the end.
Excellent. And Charles?
So I guess I'll close with 2 things. The first is that the IgG4 discussion that you just had is part of the mix of population-wide global scale immune dysregulation. And on top of that, you have these billions of doses of these mRNA jabs. And so that is an example of a bioweapon, an intrinsic agent, time shift in science. And so the second thing that I will say is that as a non-scientist, speaking to doctors and scientists, the way that we get out of this is courage and integrity and leadership. I know that everybody in this group has shown that courage, and that's exactly what we need. And so I'm grateful to have been a part of this, and I look forward, because we're going to keep fighting until we win.
Excellent, excellent. Thank you, Charles. Thank you. Thank you again to everyone. And again, it's a reminder that we have part 2 of our conference that is on Sunday at 6 p.m. UK time again. And this time we'll be focused more on some clinicians looking at therapies that they've been using with some success across the world. As I said, this full presentation will be available on other platforms if we deem that it can't be seen on some of the mainstream candidates. Please learn from this. Let us see if we can reverse some of the things that have happened across the world and see if we can put the world in a better place going forward. Again, I'll ask all the speakers to wait with me for a few minutes while I play the outro video. And thank you all very much for your contribution. And have a great evening to the audience as well. Thank you.
Thank you, Emma.
Thanks for that.
Sí. No, a millones no. ¿Cómo crees?